These eggs were laid by an animal belonging to the most successful of all reptile groups, a group that dominated the world for 100 million years.
In the beginning, the Earth was a restless planet, alive with fire and chaos. Continents had not yet taken their familiar forms, and the oceans were scattered, divided, and shallow. Molten rivers bled from the crust, reshaping the surface with every passing century. Lightning storms raged endlessly above a sky thick with volcanic gases. It was not yet a home for the world we know. It was a living machine, shifting, growing, and breaking itself apart in a rhythm of creation and destruction. Beneath this violent surface, deep inside the mantle, something powerful was stirring. Convection currents of molten rock moved like great invisible rivers. They pushed against the crust, forcing entire slabs of land to drift across the planet's surface. Continents collided, merged, and separated, over and over again in a slow and eternal dance. It was from this movement that something extraordinary would eventually emerge, the birth of Pangaea, a world united as one. The story began around 335 million years ago. Life already flourished in the oceans, fish with bony armor, trilobites crawling across the seabed, and vast coral reefs teeming with color. On land, giant forests of ferns and towering lycopods reached high into the humid air. Amphibians moved awkwardly between land and water, while insects with wings the size of birds dominated the skies. The earth was rich with life, but while creatures fought for survival above, the greatest transformation of all was happening beneath. The continents of that time were scattered pieces of older supercontinents, remnants of landmasses like Rodinia and Columbia. They drifted slowly, carried by the planet's molten currents. Laurentia, Gondwana, Baltica, Siberia, and smaller fragments were all moving toward one another, drawn together by the invisible hands of tectonic motion. As these continents inched closer, the oceans between them began to close. The Iapetus Ocean, once vast and full of life, was slowly devoured as one plate slid beneath another. The ocean floor crumpled, giving birth to new mountain chains that stretched across entire regions. Volcanic eruptions filled the skies with ash and molten rock, reshaping coastlines and altering climates. These collisions were relentless, unstoppable, and deafening on a planetary scale. With every impact, with every merging landmass, a new chapter of the planet's evolution was written. The continents collided with unimaginable force, and from those collisions rose the foundations of mountains that still stand today: the Appalachians, the Urals, the Atlas Ranges. These mountains were scars of union, proof of the time when Earth's lands became one body. Over tens of millions of years, the merging continued. Africa drifted toward North America, while Europe locked with Asia. The southern continents of Gondwana fused with the northern masses of Laurasia. Slowly, all the pieces came together. Finally, around 300 million years ago, they formed one vast, unbroken supercontinent. Its name would echo through time: Pangaea. It was a colossal landmass that stretched nearly from pole to pole. Its size was unimaginable. From one side of Pangaea to the other, it could take months for winds to travel. It covered nearly a third of the planet's surface and was surrounded by one endless ocean, the Panthalassa. To the east lay another smaller sea, the Tethys, separating Pangaea's interior from what would one day become Europe and Asia. But such immensity came with a cost. The sheer size of Pangaea disrupted the Earth's climate in ways the planet had never seen before. The edges of the supercontinent, near the coasts, were lush and humid. Heavy rains nourished vast forests, and river systems carved deep paths through fertile soil. Life flourished here. Amphibians, reptiles, and early synapsids, mammal-like creatures, ruled the swamps and forests. But the interior of Pangaea was another story entirely. So far from the ocean, the center received almost no rainfall. Clouds that formed over the sea lost their moisture long before reaching the interior. What remained was a vast desert, stretching endlessly in all directions. Scorching days and freezing nights defined this barren heartland. Sandstorms the size of countries rolled across the dunes. Nothing could survive here for long. It was a land forgotten by the rain. The contrast between coast and core defined the character of Pangaea, a world of extremes united under one sky. Beneath this massive landscape, the planet's mantle never rested. It churned and twisted, driving tectonic plates like slow, grinding gears. When one plate sank beneath another, volcanoes rose from the depths. Rivers of lava crawled across the land, cooling into black plains of basalt. Entire regions were reshaped again and again, erasing mountains and birthing new ones. It is almost impossible to imagine the power at work. Continents moved at a pace no living creature could notice just a few centimeters each year. Yet that steady movement carried the force to reshape oceans, raise mountains, and destroy worlds. Scientists have pieced together this ancient story from clues hidden deep within the Earth. Identical fossils found on continents, now thousands of kilometers apart, show that they were once joined. Rocks from distant lands align perfectly in composition and age. Mountain chains, separated by oceans, match like broken pieces of a puzzle. And magnetic minerals inside ancient rocks reveal the direction of the poles as the continents drifted, a silent record of their long journey across the planet. From these fragments, the image of Pangaea emerges a single, massive continent surrounded by water, ruled by fire and storm. Its creation reshaped the global climate. Ocean currents that once flowed freely now collided with the edges of the supercontinent. Warm equatorial waters were trapped, while cold polar currents deepened. Global temperatures began to shift. Intense seasonal contrasts appeared: boiling summers and freezing winters. Monsoons swept the coastal regions, and violent storms lashed the forests. On the edges of Pangaea, the air was alive. Thick vegetation thrived, feeding massive networks of life. Amphibians hunted in shallow lakes. Insects grew to monstrous sizes, their wings buzzing through heavy air rich in oxygen. Reptiles, small, agile, and cunning, emerged as new masters of the land. They were the ancestors of the giants yet to come. These early reptiles learned to thrive in the heat, laying eggs that could survive on dry land. They became the pioneers of a new era, creatures perfectly suited for the coming challenges of a drier, harsher world. Meanwhile, deep in the interior, only the hardiest forms of life endured. Fossilized footprints tell of reptiles that once crossed endless sand dunes, leaving behind trails that stretch for kilometers. Their bones, found in the cracked remains of dried riverbeds, whisper stories of survival and death in a world without mercy. But Pangaea was not just a geological wonder, it was a biological crucible. Its creation brought isolation and opportunity. Creatures once separated by oceans could now travel freely across vast new lands. Species mixed, evolved, and spread. Predators hunted beyond their old territories. Prey migrated to find new habitats. Ecosystems collided, adapted, and sometimes vanished. This period of unification created one of the most diverse evolutionary landscapes in Earth's history. Yet, it was also fragile. Each shift in temperature, each volcanic eruption, and each climate swing left lasting scars. As millions of years passed, the forces that built Pangaea continued to work beneath it. The pressure under the crust grew, silent and unseen. Volcanic activity increased in certain regions. Deep faults began to form, invisible cracks stretching across thousands of kilometers. The Earth's inner heat was restless, pushing upward, searching for release. Even as Pangaea stood united, the seeds of its destruction were already in motion. The mantle currents that had once brought the continents together were changing direction. Plumes of molten rock began to rise beneath the crust, weakening it from below. At first, the signs were subtle small rifts, local earthquakes, minor volcanic outbursts. But over time, these cracks would grow. What had once united the planet would one day tear it apart again. For now, though, the world belonged to Pangaea. Its landscapes stretched endlessly under a golden sun. Mountains pierced the clouds, deserts burned under open skies, and forests whispered with life. Vast rivers carried sediment across continents, feeding deltas that stretched for hundreds of kilometers. The nights over Pangaea were unlike anything seen today. With no cities, no artificial light, the stars glowed like frozen fire across the black sky. Meteors streaked above silent deserts. The air was heavy and still, broken only by the distant rumble of volcanoes. The earth was alive, breathing, shifting, waiting, and within that stillness, the planet was preparing for its next great story. The rise of Pangaea was both a triumph and a warning. The unification of all lands changed everything: climate, life, and the balance of the world itself. It was a reminder that even the most stable structures are temporary. Continents, like all things on Earth, are born to move. Millions of years after its formation, Pangaea would begin to break apart. The same forces that built it would tear it open, piece by piece, giving birth to the continents we know today. But for this brief chapter in Earth's history, all lands were one. And in that unity, the planet revealed both its power and its fragility. Earth had proven once again that creation is never still, that even in its greatest moments of calm, it is only gathering strength for the next transformation. Pangaea was a world of beauty and brutality, a land of opposites, held together by a single heartbeat, the planet's molten core. Everything about it was vast. The mountains, the deserts, the storms, and even the silence. It was a planet that pushed the limits of what life could endure. From one end of the supercontinent to the other, extremes ruled. The size of Pangaea itself created the imbalance. With so much land gathered in one place, the climate had no balance point. Near the coasts, the air was thick with humidity, alive with the sounds of forests and rivers. Rain fell almost endlessly, turning the soil dark and fertile. Plants grew in wild abundance, wrapping the land in green canopies that stretched for hundreds of kilometers. But the farther one traveled from the ocean, the more the world began to change. The air grew dry, the soil turned red, and the rain disappeared completely. The horizon became a mirage, swallowed by waves of heat. At the heart of Pangaea lay a desert larger than any seen before or since, a barren expanse where life itself seemed to hesitate. Day after day, sunlight burned across the land, creating temperatures that would have melted modern instruments. In this central desert, even wind became a sculptor. Dunes taller than mountains drifted across the landscape, swallowing forests and carving canyons into the bones of the earth. At night, when the heat vanished, the cold arrived with equal cruelty. Frost formed on cracked stones, and the air turned so thin it hurt to breathe. Nothing remained constant here. It was a land of endless change, shaped by the slow rhythm of planetary breath. Life, though rare, still found a way. Small reptiles moved like ghosts between rocks, their scales glimmering with dust. They hunted insects that burrowed into the sand, living off moisture drawn from the air. Some grew protective shells, others developed the ability to conserve water for weeks. Every creature that survived here was a product of evolution's harshest test. In the cracks between dunes, occasional rainstorms, rare and violent, brought brief moments of life within hours. Seeds buried deep beneath the sand would awaken. Fragile plants would bloom, color flooding the desert for a single day before vanishing again into dust. This was Pangaea's heart, a land of suffering, beauty, and survival. But along the edges of this massive supercontinent, an entirely different world existed. Here, the ocean shaped everything. The coasts of Pangaea were alive, bursting with ecosystems of astonishing diversity. Rivers poured down from the mountains, carrying minerals and sediments to the sea. Deltas formed where land met water, creating fertile wetlands teeming with creatures. Amphibians thrived, their slick bodies reflecting the sunlight. Giant ferns and early conifer trees dominated the landscape, rising above moss-covered ground. Insects ruled the skies. Dragonflies with wingspans wider than a man's arm glided through humid air, preying on smaller insects that filled the air with constant motion. The sound of life was everywhere, buzzing, croaking, rustling, echoing through the thick forests that lined the coastal plains. But the forests were more than just homes for animals, they were the engines of the atmosphere. The plants of Pangaea were transforming the planet itself. Through photosynthesis, they pulled carbon dioxide from the air and released oxygen in its place. Over millions of years, oxygen levels in the atmosphere began to rise. This shift made the air denser and more breathable, fueling the growth of enormous life forms. The insects grew larger, amphibians became more active, and early reptiles found new opportunities to evolve. These creatures would become the rulers of the next great era. Yet, this abundance came with instability. The global wind patterns, disrupted by the size of Pangaea, created unpredictable weather. Near the coasts, heavy rains and thunderstorms were common. Entire regions could flood within hours, then dry out completely within days. Monsoon systems of unimaginable strength swept across the land, powered by the massive temperature differences between the ocean and the desert interior. Storms here were colossal. Walls of dark clouds stretched across the horizon, lit from within by flashes of lightning. Thunder rolled like the voice of the earth itself. Rain fell so heavily it reshaped the ground, carving new rivers and filling vast inland basins with temporary lakes. But these rains never reached the desert's heart. The distance was simply too great. In some regions, forests turned to swamps, and swamps turned into coal fields that would one day fuel the fires of human civilization. These dense wetlands were rich in organic matter, fallen trees, decayed plants, and buried leaves compressed over millions of years into thick layers of black carbon. The coal we burn today is a gift from Pangaea's ancient forests, a memory of that lush and volatile age. Beneath the surface, the planet continued its endless motion. Tectonic plates strained against each other, bending, twisting, and cracking. Deep within the mantle, molten rock surged upward, creating chains of volcanoes that ran like scars across the land. These eruptions spewed ash and gas into the sky, sometimes blocking sunlight for months. In moments like these, the entire planet trembled. Temperatures dropped suddenly, ecosystems collapsed, and countless species vanished. Volcanic winters swept across the land, choking the skies in darkness. Yet, once the ash settled, new life always emerged. This cycle of destruction and renewal was the heartbeat of Pangaea. It was a reminder that life and death were not opposites, but partners in the same eternal dance. The geological forces shaping the land also sculpted the oceans. Panthalassa, the single great ocean surrounding Pangaea, was a world unto itself. Its vastness dwarfed anything that exists today. Powerful currents circled the supercontinent, moving heat and energy across the globe. The deep waters were cold and silent, but near the coasts, life flourished in abundance. Ancient reefs built from corals and sponges stretched for hundreds of kilometers. Within them lived an entire universe of creatures. Ammonites with spiral shells, early sharks gliding through the shadows, and armored fish darting between rocks. Beneath the waves, volcanic ridges created new islands, while underwater eruptions sent shockwaves that echoed through the sea. Yet life in these waters was resilient. Even after global extinctions, the ocean always found a way to recover faster than the land. It was the Earth's sanctuary, the cradle that would give rise to new forms of life after every catastrophe. The balance of this world was fragile. The same processes that made it vibrant could also destroy it. As the supercontinent stabilized on the surface, the interior of the planet was becoming restless again. Heat built up beneath Pangaea's crust. Unable to escape, pressure increased, pushing upward. Deep fissures formed, stretching across the land like veins of fire. In some places, lava poured freely from the ground, spreading in massive flows that hardened into black plains. Gases filled the atmosphere, changing its chemistry. Carbon dioxide levels fluctuated wildly, altering temperatures and ocean acidity. These changes triggered smaller extinction events, erasing some species entirely while opening space for others to rise. Amphibians, once dominant, began to struggle in the growing dryness. Reptiles adapted better. They could travel farther from water, survive on less, and endure the extreme heat of the interior lands. This gradual shift marked the beginning of a new age on Earth, the dawn of the reptiles, the early ancestors of the dinosaurs. As the land continued to transform, so did the skies. Storms became more violent as temperature contrasts intensified. Lightning ignited wildfires that swept across entire forests. For days, smoke would blot out the sun, casting the land in an orange haze. After the fires passed, new vegetation would sprout, fed by the ash that enriched the soil. This endless cycle of fire and rebirth shaped the evolution of countless species. To live on Pangaea was to live in constant motion. The Earth never stayed still. Everything was connected. The desert winds, the volcanic fire, the flowing rivers, the roaring oceans. They were all parts of one system, one pulse, one planet. Scientists studying rock formations today can still see the fingerprints of this chaotic era. Red sandstone layers mark the ancient deserts. Coal deposits tell of lost forests. Salt beds reveal the existence of vanished inland seas. Every grain, every fossil, every mineral is a fragment of that forgotten world preserved in silence. If one could stand on a mountain peak in Pangaea and look around, the sight would have been overwhelming. Endless desert stretching one way, green jungles the other, massive storms crawling across the horizon. Volcanoes glowing red at night, their light flickering against black clouds. It was a world both ancient and new, a planet still learning to balance itself. And beneath that surface beauty, the clock was already ticking. The forces that had united the continents were beginning to weaken. Cracks were forming in the crust, so deep they touched the mantle itself. Magma began to gather in these rifts, pushing upward with immense force. Though it would take tens of millions of years, this process would eventually tear Pangaea apart. For now, however, the world was whole. The animals of this era lived unaware of the grand movements beneath them. They hunted, bred, and adapted as the planet changed around them. Amphibians struggled against the spreading dryness, while reptiles claimed the land. The ocean teemed with new predators. Evolution accelerated, shaping bodies and behaviors for survival in this unpredictable environment. The forests remained dense near the coastlines, filled with the hum of insects and the distant roars of early reptilian life. Rivers glistened in the sunlight, flowing toward the vast Panthalassa, where the planet's pulse beat strongest. The atmosphere itself shimmered with potential. Higher oxygen levels fueled energy and endurance in the creatures that walked and flew. But it also meant danger. Wildfires burned hotter, storms grew stronger, and lightning became more destructive. Every advantage carried a cost. In many ways, Pangaea was the planet's greatest experiment, a natural test of extremes. What happens when all lands merge? When deserts stretch endlessly and oceans encircle everything? What happens when the planet becomes both paradise and hell at once? The answers were written not in words, but in fossils, in mountains, and in the layers of stone that still hold the memory of that age. Pangaea was more than a place. It was an era of transformation. The Earth itself was learning how to balance chaos with creation. And from that chaos, new life would emerge, stronger, faster, and more adaptable than ever before. This was the foundation for the next great chapter of evolution, the beginning of the world that would soon belong to the dinosaurs. The age of Pangaea was not just a story of land. It was also the story of an ocean so vast, so endless, that it wrapped around the entire planet like a deep blue ring. This was Panthalassa, the mother of all oceans. It surrounded the supercontinent completely, stretching beyond the horizon in every direction, a watery world larger than anything that exists today. To stand on the shores of Pangaea and look toward Panthalassa was to gaze into infinity. The waves never stopped. Winds blew across thousands of kilometers without meeting a single island or landmass. Storms grew monstrous as they gathered energy over open water, their roars echoing across the supercontinent's coasts. It was a planet ruled by water and silence. The surface of Panthalassa shimmered under the ancient sun, but beneath that surface, an alien world thrived, one of darkness, color, and motion. The ocean was alive, filled with creatures that seemed both familiar and strange. At the time of Pangaea, much of the planet's life still belonged to the sea. Even though reptiles and amphibians had begun to claim the land, the ocean remained the center of evolution, the cradle of diversity. Beneath the waves, coral reefs stretched across shallow shelves, glowing with the colors of strange sponges, anemones, and early corals. Schools of small fish swam through their labyrinths, chased by sleek predators that had evolved to hunt with precision and speed. Trilobites, though fading from dominance, still scuttled along the sea floor, their armored shells reflecting the dim light filtering from above. Further out, where the sunlight could not reach, the waters turned cold and black. Enormous creatures roamed these depths, primitive sharks, giant ammonites with spiral shells, and early forms of squid. Their soft bodies glowed faintly with bioluminescent light, a ghostly blue shimmer that drifted like stars in the deep. Currents moved like invisible highways beneath the surface. They circled Pangaea, carrying warmth from the equator to the poles and bringing nutrients from the deep back to the surface. These global currents shaped the planet's climate and dictated where life could thrive. But the vastness of Panthalassa was not calm. Its power was ancient and unpredictable. Tectonic ridges ran through its center, where molten rock pushed upward from the mantle, creating new ocean floor. As this sea floor spread outward, it pushed the continental plates together, an unstoppable force that had helped form Pangaea itself. Along the edges of the oceanic crust, where the seafloor sank back into the mantle, deep trenches formed dark scars that plunged thousands of meters into the earth. Here, the pressure was unimaginable, the darkness complete. Strange, eyeless creatures drifted in the abyss, feeding on what little organic matter fell from the world above. Volcanic activity beneath Panthalassa was constant. Underwater eruptions spewed plumes of minerals and gas into the sea, creating hydrothermal vents that became oases of life in an otherwise barren deep. These vents glowed with chemical fire, releasing heat and minerals that sustained entire ecosystems. Around them lived tube worms, crustaceans, and microorganisms that fed not on sunlight, but on the chemistry of the Earth itself. It was here, in the silent darkness of Panthalassa's depths, that evolution experimented endlessly. Life found ways to exist in places where no light reached, no oxygen flowed, and no warmth touched. The ocean's abyss was both a grave and a birthplace. On the surface, storms raged without rest. With no other continents to break their strength, winds could circle the globe freely. The ocean's waves towered like walls, crashing against Pangaea's cliffs with unimaginable force. During the height of these tempests, lightning flashed across the skies, illuminating the entire coastline in pulses of white fire. Rains fell in torrents, feeding rivers that carved deep paths into the land. These rivers carried sediments back to the sea, creating massive deltas and shallow bays filled with nutrients. Every flood, every storm, brought new life to the ocean's edge. This constant exchange between land and sea was the heartbeat of Panthalassa. Near the equator, where sunlight was strongest, the ocean's surface teemed with plankton. These microscopic organisms formed the base of the marine food chain, feeding countless species of fish and invertebrates. Where plankton flourished, life exploded in numbers, reefs expanded, fish populations surged, and predators grew larger to feed on them. In these warm, shallow waters, evolution accelerated. New species appeared, adapted, and vanished in a constant cycle of survival. Each generation pushed further, faster, and stranger. Some fish developed harder scales for protection. Others grew faster or sharper teeth. Ammonites evolved new shell shapes to help them float and maneuver better. It was a silent arms race beneath the waves. Deeper into the ocean, where the sunlight faded to a faint green glow, larger creatures dominated. Early sharks ruled the middle waters, sleek and powerful, their senses tuned to detect the faintest movement. They were the undisputed predators of Panthalassa, moving through the depths like living torpedoes. But even the sharks were not alone. Giant marine reptiles, descendants of land-dwelling ancestors, began to enter the seas. They were not yet the great ichthyosaurs and plesiosaurs that would one day rule, but they marked the beginning of a transformation life returning to the element it had once left behind. These early marine reptiles learned to hunt underwater, developing streamlined bodies and powerful tails. Over time, they would adapt completely to ocean life, giving birth to new forms that would dominate the Triassic seas. The coastlines of Pangaea were where two worlds met, the living sea and the restless land. Tidal pools formed at the edges, trapping small fish and shellfish as the waves receded. Amphibians crept between water and soil, their wet skin glistening in the sunlight. The transition between ocean and land was never still. It was a place of constant evolution, where life tested new ideas with every tide. Each generation that passed carried small changes, small advantages, that would eventually shape the entire history of life on Earth. Systems collapsed. Entire species could vanish within decades. The balance of this ocean world was fragile, held together by the thin line between temperature and chemistry. Every eruption, every shift in current could tip that balance. Scientists today can still trace the scars of Panthalassa in the rocks of modern ocean floors. Though much of it has long been destroyed by the constant recycling of Earth's crust, fragments remain ancient seafloor basalts buried deep within mountain ranges, carried upward by the collision of continents. These stones whisper the memory of a sea that once wrapped the world. The movement of Panthalassa's currents also helped shape Pangea's weather. As warm waters flowed toward the northern coasts, they brought rain and humidity, creating lush forests and river valleys. Cooler currents from the south kept other regions dry and barren. It was this contrast that created Pangea's two-faced nature, a world of water and desert, of floods and droughts. The great ocean was more than just water. It was the planet's mirror, reflecting the sky, the storms, and the shifting light of the sun. Every day, clouds formed above it, fed by evaporation. Every night, the heat stored in its depths rose into the air, driving the planet's winds and shaping its climate. Without Panthalassa, Pangaea could not have existed. The ocean's vast pressure and temperature balance helped stabilize the planet, keeping it from burning or freezing completely. It was both the Earth's heart and its lungs. In the calm after a storm, the surface of Panthalassa would glitter like polished glass. Distant volcanoes erupted along its horizon, glowing red against the darkness. Lightning flickered over the waves. Beneath that still surface, entire ecosystems continued their endless cycles of birth and death. The sound of this ocean would have been unlike anything heard today, a constant roar, the deep voice of a living planet. The wind would howl across the waves, echoing off Pangea's cliffs, carrying the scent of salt and ash. If one could fly above this ancient world, looking down from the edge of the sky, the sight would have been breathtaking. A single landmass surrounded by one infinite sea, deserts glowing orange in the sun, green forests hugging the coasts, black volcanoes smoking along the edges, and all around, stretching to the curve of the horizon, the endless blue of Panthalassa. It was both a boundary and a bridge, a place of danger and life, of silence and fury. For within the depths of Panthalassa, change was already beginning. The seafloor ridges that had once pushed the continents together were now reversing direction. New rifts began to form beneath the ocean, releasing heat and pressure upward. Slowly, the ocean's invisible machinery started to turn again, setting the stage for Pangea's eventual breakup. Millions of years later, when Pangaea would finally split apart, the cracks would first open along its coasts, rifts born from the restless energy of Panthalassa. From these wounds, the Atlantic Ocean would one day emerge. But during its reign, Panthalassa was eternal, a boundless sea that carried life, death, and the memory of creation. Every ripple on its surface was a whisper of time, every wave a reminder that the earth itself was alive and dreaming. And though this ocean is gone, replaced by the divided seas of today, its essence remains in every drop of salt water on the planet. The Pacific, the Atlantic, the Indian, the Arctic, all of them are pieces of Panthalassa's soul. It was the ocean that watched the rise of the continents, the birth of mountains, and the evolution of life. It was the ocean that carried the reflection of the first dawns and the last sunsets of an age. And even now, in the rhythm of our tides, the sound of Panthalassa still echoes. Life on Pangaea was both a miracle and a mystery. For the first time in Earth's history, nearly all of its land was connected. From pole to pole, from coast to desert, the world's creatures could wander freely across one massive continent. The barriers that once separated species were gone. Oceans no longer divided evolution. Rivers, forests, and mountains now formed endless corridors of life. It was a time of unity, but also a time of struggle. The very size of Pangaea created brutal extremes in climate and geography. Near the edges, life flourished in abundance. Near the center, life barely held on. Evolution had to adapt fast to a planet that offered both paradise and punishment within a single horizon. The coasts of Pangaea were green worlds of endless vitality. Vast river systems spilled into the sea, creating fertile deltas filled with reeds, moss, and ferns. Forests of tall lycopods and horsetails stretched high, their leaves capturing sunlight in thick layers. These ancient plants breathed life into the planet's air, pumping oxygen into an atmosphere already rich and heavy. In the shade of these forests, amphibians thrived. Their slick, glistening bodies moved between water and land with ease. Some grew as large as crocodiles, their jaws lined with needle-sharp teeth. They hunted fish in shallow streams and hid beneath fallen logs to ambush insects the size of birds. Their croaks echoed through the humid air, merging with the constant hum of life around them. Above them, the skies buzzed with wings. Dragonflies, damselflies, and strange early insects filled the air like living clouds. Their wings shimmered in the sunlight, catching the wind as they glided above the forests. Some dragonflies reached wingspans wider than a man's shoulders, their size made possible by the thick oxygen-rich atmosphere. These insects ruled the air long before birds ever existed. On the ground, reptiles were rising. Smaller and more resilient than the amphibians, they could survive farther from water. Their scales protected them from the heat, and their eggs could hatch safely on land without drying out. They were the first true land conquerors, creatures built for independence. Over millions of years, these early reptiles would diversify into many forms. Some remained small and quick, feeding on insects. Others grew larger, evolving powerful limbs and stronger jaws. Their bodies became more efficient, their lungs more advanced. They were the blueprint for the reptiles, dinosaurs, and mammals that would follow. The forests and swamps of Pangaea were their kingdom. Every corner of this green world pulsed with life. The air was thick, damp, and heavy with the scent of earth and water. Everywhere there was sound, the constant buzzing of insects, the splash of amphibians, the deep rumble of distant thunder. But travel inland, away from the coasts, and the story began to change. The dense forests slowly gave way to dry plains. Rivers thinned, and vegetation grew sparse. Eventually, the land turned to desert, stretching endlessly in every direction. This was the interior of Pangaea, a region so vast that rain rarely reached it. Clouds formed over the oceans, but lost their moisture long before they could cross the supercontinent's heart. Here, the soil cracked beneath the heat. The wind carried dust for hundreds of kilometers. Temperatures soared by day and plummeted at night. Yet even in this barren landscape, life endured. Reptiles dominated the deserts. Their bodies were built for survival. Thick scales prevented water loss, and their blood could tolerate extreme temperatures. Small, agile predators hunted lizards and insects among the dunes. Herbivorous reptiles, low to the ground, fed on the few tough plants that grew in the sand. These creatures represented the resilience of life, the ability to adapt, evolve, and thrive even in the harshest conditions. Fossil evidence shows that some species traveled vast distances across Pangaea. Footprints preserved in ancient mud tell stories of migration, of creatures moving toward better climates as the seasons changed. Herds of early reptiles likely followed rivers and lakes, feeding where they could before the dry season returned. This endless movement shaped their evolution, making them stronger, faster, and more intelligent. While the interior deserts baked under the sun, the polar regions of Pangaea told a colder tale. During the late Permian and early Triassic, ice still gripped parts of the southern supercontinent. Glaciers carved deep scars into the rock, and snow covered the highlands for much of the year. Even here, life persisted. Primitive plants and cold-tolerant reptiles clung to survival, adapting to long periods of darkness and cold. This contrast between the frozen south, the burning center, and the tropical coasts made Pangaea a world of extremes in every sense. No other time in Earth's history had seen such diversity in climate on a single connected landmass. The constant shifts in temperature and weather drove evolution to new heights. Species that couldn't adapt perished quickly, leaving only the strongest to continue. Those that survived learned to master both heat and cold, both drought and flood. In the coastal regions, where conditions were more stable, ecosystems grew more complex. Amphibians gave rise to the first true reptiles. Fish in the rivers evolved new forms to handle changing currents and oxygen levels. On the ocean's edge, plants began developing tougher stems and deeper roots to withstand floods and storms. The forests themselves became laboratories of evolution. High canopies blocked sunlight, forcing smaller plants to adapt to darker conditions. Ferns developed larger leaves to capture light, while vines climbed trees to reach the sun. Each new adaptation created another opportunity for life to evolve. Insects adapted alongside them. Some grew specialized mouths to feed on tough plant fibers. Others developed camouflage to hide from predators. A few even began early forms of cooperation, building nests and defending territory. This was the silent beginning of behaviors that would later define the animal kingdom. As millions of years passed, the diversity of life on Pangaea continued to grow. Rivers teemed with fish and amphibians. Swamps echoed with the sounds of croaking and buzzing. Deserts shimmered with the quiet footsteps of reptiles moving through the sand. And above it all, volcanoes erupted in distant mountain chains, releasing smoke that drifted across the horizon like ghosts. But the harmony of Pangaea was fragile. Beneath the ground, the planet's heart never stopped moving. Tectonic pressure built steadily, unseen but unstoppable. Each shift deep below the surface caused earthquakes and volcanic eruptions that reshaped the land. Sometimes entire ecosystems vanished overnight. Forests buried in ash. Rivers diverted. Lakes boiled into clouds of steam. Yet every destruction opened the door for new beginnings. Volcanic ash fertilized the soil, and within years, green life returned stronger than before. This endless cycle, creation, destruction, rebirth, defined Pangaea's living systems. And as time passed, one species began to stand out above all others: the synapsids. These were reptile-like creatures with traits that would one day give rise to mammals. They were warm-blooded pioneers in a cold-blooded world, capable of surviving where others could not. Their jaws were more advanced, their teeth more specialized. They hunted with purpose, and some cared for their young, an early spark of intelligence that hinted at the future of life on Earth. In the humid forests, other lineages began to evolve towards something even more remarkable. The first archosaurs, ancestors of crocodiles, pterosaurs, and eventually dinosaurs, appeared during this time. They were agile, efficient predators with upright stances and fast metabolisms. They marked the beginning of a new era, the rise of dominance on land. The ecosystems of Pangaea were now rich with competition. Every niche was filled. Herbivores grazed in the swamps, predators stalked them from the shadows, and scavengers cleaned what remained. The web of life stretched farther than ever before, linking every creature, every plant, every grain of sand into a single living system. Above it all, the atmosphere shimmered with energy. Lightning storms flashed through the clouds. Winds carried pollen and spores across the vast continent, spreading life to distant regions. What one forest produced could take root thousands of kilometers away. This global connectivity was both Pangaea's gift and its curse. While it allowed life to spread freely, it also meant that disaster could spread just as quickly. A single drought, a volcanic eruption, or a temperature shift could affect the entire world at once. Extinction on Pangaea was never local, it was global. Scientists believe that toward the end of Pangaea's reign, massive volcanic events, known as the Siberian Traps, unleashed one of the most devastating extinctions in Earth's history. Lava poured across millions of square kilometers. Toxic gases filled the air. The oceans turned acidic, and the atmosphere darkened. More than 90% of all species vanished. But even this catastrophe could not erase life entirely. From the ashes of extinction, survivors emerged small reptiles, early mammals, and marine species that adapted to new conditions. Once again, the planet rebuilt itself. The story of life on Pangaea was not one of peace, but of resilience. It was a world that demanded strength from every living thing. To survive here meant adapting to fire, flood, heat, and cold. It meant being shaped by a planet that never stopped changing. The forests that once covered its coasts would become coal beds. The deserts that scorched its center would become stone. The rivers that carved its valleys would dry into fossils of ancient currents. But in those rocks, the memory of Pangaea remains. It tells us that life, no matter how harsh the world becomes, will always find a way to begin again. And though the continents have long since drifted apart, the echoes of Pangaea's living world still run through our veins. Every tree, every animal, every breath of air carries the legacy of that ancient land when Earth was whole, when all creatures shared one home, and when life learned to rise through extremes. The great silence that followed the world's worst extinction hung over the planet like a heavy shadow. More than 90% of all life had vanished. The oceans were empty, the forests were gone. The air itself had changed. For a moment in time, Earth stood still, scarred by its own fury. This was the beginning of the Triassic period. It was an age born out of fire and ruin. Pangaea, the united supercontinent, still dominated the world, stretching from the frozen poles to the burning equator. But now, its surface was marked with the wounds of catastrophe. Volcanic plains blackened by ash, riverbeds turned to stone, and deserts that stretched for endless horizons. The planet had just survived the Permian extinction, a cataclysm triggered by volcanic eruptions so massive that they blanketed the skies with smoke for years. The Siberian Traps, vast fields of molten rock had poured lava across millions of square kilometers, releasing deadly gases into the atmosphere. Temperatures soared, oceans turned acidic, and oxygen levels fell to suffocating lows. The result was nearly the end of life itself. But life, fragile as it was, never truly dies. In the quiet aftermath, the world began to breathe again. The skies slowly cleared, the rains returned. Small plants pushed through the ashes, their roots clutching at the burnt soil. Mosses, ferns, and hardy shrubs began to spread along the rivers and coastlines. Where the land healed, life followed. From the survivors of the extinction, new species began to emerge. Amphibians, though greatly reduced in number, clung to the edges of lakes and swamps. They were slower now, smaller, and less dominant. The world that had once belonged to them was slipping away. Taking their place were the reptiles, the masters of heat and dryness. They had endured the extinction better than most. Their bodies were efficient, their lungs powerful, and their eggs safe from the drying air. They were built for this new, harsh world. From these survivors, the next rulers of Earth would rise. The early Triassic world was still strange and unstable. Volcanic eruptions continued to shape the land. Earthquakes cracked the crust. The atmosphere carried a sharp tang of sulfur. The climate swung between extremes, burning summers and freezing winters, violent storms and long droughts. Yet within this chaos, evolution was rewriting the planet's story. The reptiles began to diversify. Among them were small, fast-moving creatures with upright stances and long tails for balance. They were predators, hunters that chased their prey rather than waiting for it. Their legs no longer sprawled sideways like those of lizards. Instead, they stood beneath their bodies, giving them strength and speed. These were the first archosaurs, the ancestors of crocodiles, pterosaurs, and eventually dinosaurs. Their rise was quiet at first, unnoticed in the shadow of larger, slower creatures that still roamed Pangaea's forests. But the archosaurs had advantages that no other animal could match. Their bodies were efficient machines, capable of conserving energy and surviving extreme conditions. They could run faster, breathe deeper, and stay active longer. They were built for dominance. As the climate stabilized, vegetation returned in abundance. Forests grew back along the coasts, while the interior deserts shrank slightly under changing winds. Rivers once again carried life across the land, forming ecosystems of swamps, plains, and forests. Insects filled the air, feeding on the new vegetation. The earth was alive again, but it was a different kind of life, faster, leaner, and more aggressive. In these new ecosystems, predators and prey began to evolve in tandem. Early crocodile-like archosaurs lurked near rivers, ambushing small reptiles and amphibians. Herbivorous species, low to the ground and heavily armored, grazed on ferns and cycads. Above them, the first small pterosaurs glided through the air, their wings stretched thin like parchment. They were not yet masters of the sky, but they were its pioneers. The Triassic dawn was a world in transition. Nothing stayed the same for long. Species appeared, thrived, and vanished in the span of a few million years. On the western edges of Pangaea, the land was dotted with volcanic lakes and steaming vents. These regions were dangerous but fertile. Minerals from the Earth's depths enriched the soil, allowing plants to grow quickly after eruptions. In turn, these plants fed herds of herbivores, early relatives of what would one day become dinosaurs like plateosaurs and prosauropods. These early giants walked on 4 legs, their long necks reaching into the trees. They were slow but strong, feeding constantly to sustain their massive bodies. Predators hunted them, but none yet possessed the intelligence or coordination of the hunters that would come later. As time passed, new species of archosaurs evolved, each more specialized than the last. Some grew larger and heavier, ruling the rivers and lakes like modern crocodiles. Others became smaller and faster,
the cool thing
sprinting
is that no one
across
is
open
uploading
plains in
urbex or
packs. These smaller forms would eventually give rise to the true dinosaurs, the creatures that would dominate the next 160 million years. But the first dinosaurs were not the towering beasts of the Jurassic or the armored titans of the Cretaceous. They were small, nimble, and clever. Around 230 million years ago, in the late Triassic, the first true dinosaurs appeared. Creatures like Eoraptor and Herrerasaurus, both less than 2 meters long, roamed the forests and plains of Pangaea. They were light, fast, and alert. Their legs were positioned directly beneath their bodies, giving them powerful strides. They hunted small reptiles, insects, and mammals, using sharp teeth and claws to bring down their prey. Though they were few in number, they were unlike anything that had come before. Their speed, endurance, and intelligence made them unstoppable. Evolution had found its next great design. The rise of these early dinosaurs marked a turning point not just for life on land, but for the planet itself. The ecosystems of Pangaea began to shift around them. Predators grew faster to compete, prey evolved new defenses, and plants developed tougher leaves and new forms of reproduction to survive being eaten. Every life form adapted to the growing dominance of these agile hunters. In the skies above, another revolution was taking place. The first flying reptiles, pterosaurs, began to master the air. Their wings, made of stretched skin, supported by elongated fingers, allowed them to glide long distances over the forests and seas. They hunted fish and small land animals, diving from above with precision. For the first time in Earth's history, the sky was no longer empty. Beneath them, the Earth was alive with new sounds. The calls of reptiles, the chirping of insects, and the rustle of leaves filled the air. The planet had recovered from its great dying. The Triassic dawn was no longer a time of survival, it was a time of expansion. As the land grew fertile, so too did the oceans. Panthalassa began to heal. Coral reefs returned to the shallow waters, teeming once again with fish, ammonites, and early marine reptiles. Ichthyosaurs, resembling modern dolphins, but far more powerful, glided through the seas with unmatched grace. They were the ocean's new rulers, evolved from land reptiles that had returned to the water in search of food. Their speed and intelligence gave them dominance over the deep. Their large eyes allowed them to hunt even in low light, and their streamlined bodies could outswim nearly anything. They shared the seas with the massive nothosaurs, long-necked predators that hunted near the surface. The world was filling up again. The Earth was alive, fierce and restless. But even as life spread across the land and sea, Pangaea itself was beginning to feel the first signs of tension beneath its surface. Tectonic forces were building pressure deep below. The crust, still recovering from centuries of volcanic violence, began to stretch and crack. Earthquakes became more frequent. Volcanoes erupted in chains along fault lines, sending clouds of ash into the air. These tremors were warnings of what was to come, the slow but inevitable breakup of Pangaea. For now, though, the supercontinent still stood united, and the creatures that walked its soil were thriving. Forests covered the coasts, deserts spread across the center, and the poles remained frozen and silent. The planet had found a temporary balance. This was the world of the Triassic dawn, a world rebuilding itself from extinction, creating the foundation for everything that would follow. In the deserts of the interior, small dinosaurs chased insects beneath the heat. In the forests, herbivores grazed in herds, while predators watched from the shadows. Along the coasts, amphibians croaked from the water's edge, unaware that their time was ending. And in the skies, the pterosaurs soared above it all, watching a planet reborn. The dawn of the Triassic was not a peaceful rebirth, it was a battle for dominance. Every living thing fought to claim its place in the new order. The strong adapted, the weak vanished, and evolution continued its relentless march forward. This was the beginning of the age of the reptiles. The age of giants was coming, and from the ashes of the world's greatest extinction, life had not only survived, it had learned to conquer. The center of Pangaea was a place of silence. It stretched for thousands of kilometers, a heart of stone and dust surrounded by green coasts and dark seas. No wind from the ocean could reach this far. No rain cloud could survive the journey across its vast interior. It was a world within a world, an endless desert where the sun ruled without mercy. Here, the air shimmered like glass. Heat rippled above the dunes, and the ground burned beneath the feet of anything brave enough to walk it. Rocks cracked under the weight of the sun. Sandstorms rose without warning, swallowing the horizon in orange haze. The heart of Pangaea was not meant for life, yet life, stubborn as ever, refused to die. These deserts were the result of Pangaea's immense size. With all the continents joined together, oceanic winds that carried moisture from the Panthalassa ocean lost their strength long before reaching the interior. Without rain, the soil turned dry and lifeless. What little water existed came from small rivers that flowed from distant mountains, only to vanish into salt flats and dry basins. But these barren lands were not empty. They were alive, quietly and fiercely. Reptiles ruled this wasteland. Their bodies were built for survival, their blood slow and efficient. Some grew long legs to cover great distances, others flattened themselves against the rocks to avoid the burning heat. Many were nocturnal, hiding during the day and emerging at night when the desert cooled. The stars above the desert were sharp and clear, and under their light the hunters came alive. Small predatory reptiles moved quickly across the sand, leaving trails that vanished with the wind. Their prey, tiny insect-like creatures, and even smaller reptiles hid beneath stones or burrowed deep into the soil. The balance between hunter and hunted was fragile, but it had worked for millions of years. In the few regions where water pooled, life gathered like a miracle. Oases formed at the bottoms of ancient craters or along the edges of drying rivers. Here, plants grew in small patches of green, a rare sight in this sea of dust. Early cycads and horsetails clung to the edges, their roots stretching deep into the ground. Amphibians, once rulers of a wetter world, survived in these shrinking pockets, their lives tied to the few remaining pools. The struggle for survival defined the rhythm of life in the desert. There was no abundance, only endurance. Every breath, every movement, every drop of water mattered. Scientists have found fossil evidence of these ancient deserts' ripple marks frozen in stone. Dunes turned to rock, and footprints preserved in what was once wet sand. These tracks tell stories of creatures walking across the supercontinent's interior millions of years ago. They reveal how even in the harshest conditions, life adapted, evolved, and endured. The desert floor of Pangaea was not just sand. It was a record of time, layer upon layer of sediment built up over centuries, painted in shades of red, orange, and brown. These colors came from iron in the soil oxidized by the dry air and endless sun. Today, these same rocks form parts of the red deserts in North America, Africa, and Asia. The ancient bones of Pangea's interior, still visible on modern Earth. The wind shaped everything here. It carved the rocks into twisted towers and arches, eroded mountains into dust, and buried valleys beneath shifting dunes. The sound of the desert was the sound of movement, grains of sand whispering across stone, the low hum of wind over cliffs, the faint hiss of air escaping from cracks in the ground. In some places, volcanic activity had scarred the landscape. Ancient lava fields cut through the desert like black rivers, frozen in time. These regions were dangerous, filled with sharp rocks and poisonous gases that leaked from below. Yet even here, life persisted. Small ferns grew between cracks, feeding on the minerals brought up from the deep. The creatures of Pangea's deserts were not large, but they were extraordinary. Early archosaurs, the ancestors of crocodiles and dinosaurs, roamed the edges of the dry plains. Their bodies were streamlined, built for speed and endurance. They hunted smaller reptiles and scavenged for whatever they could find. Some species grew bony armor along their backs, protection against both predators and the harsh sun. Fossilized footprints show how they moved in groups, perhaps following seasonal routes between water sources. These migrations would have taken them across hundreds of kilometers of open desert. Few survived the journey, but those who did shaped the course of evolution. Not all the desert was lifeless. Along its western edge, ancient mountain ranges cast shadows long enough to trap cooler air and occasional rain. In these regions, the land transformed into dry grasslands and scrub forests. Here, the competition between herbivores and predators was fierce. Herbivorous reptiles fed on low shrubs and tough plants, their jaws designed to crush hard leaves. Predators lean, quick, and relentless stalked them through the dust. This constant cycle of hunt and escape forged some of the most adaptive creatures of the era. The sky above the desert was a spectacle of color. At dawn, it burned orange and gold. At noon, it turned white with heat. By dusk, it deepened into blood red as the sun sank beyond the dunes. At night, the cold returned and the stars glittered like frozen fire. Meteors often streaked across the sky, their trails briefly lighting the sands. It was a world of both death and beauty, a reminder that even the harshest landscapes could inspire awe. Over time, the desert's influence spread beyond its borders. Dust carried by the wind drifted into the forests and oceans, changing the chemistry of the air and water. These tiny particles affected everything, from plant growth to the temperature of the planet. In this way, even the lifeless heart of Pangaea played a part in shaping the balance of the Earth. As the Triassic period advanced, the deserts of Pangaea expanded and contracted in rhythm with the planet's climate cycles. When volcanic activity increased, temperatures rose and the deserts grew larger. When the atmosphere cooled, rains returned and patches of green reappeared. This constant shift between drought and renewal drove the evolution of resilience. The creatures that lived here became masters of adaptation. Their bones show signs of compact, efficient lungs designed to conserve oxygen. Their skin was layered with protective scales to prevent water loss. Their eggs evolved thicker shells to survive the dry air. Everything about them spoke of survival through hardship. It was in these unforgiving lands that the ancestors of many future giants first learned to endure. The early dinosaurs, still small and fast, thrived along the desert's edge. They hunted lizards and insects in the twilight, their bodies cooled by the evening breeze. With each generation, they grew stronger, faster, and more capable of handling the extremes. They would one day inherit the world, but here, in the deserts of Pangaea, they were still students of survival. The desert was their teacher. It rewarded endurance, punished weakness, and shaped evolution through struggle. Those that adapted would conquer the world. Those that failed would vanish into the sands. The same winds that sculpted the dunes also carried seeds across great distances. When those seeds found rare patches of moisture, they sprouted quickly, grew, and scattered new generations before the heat returned. These short bursts of green brought temporary hope to the wastelands, feeding small herbivores and insects before fading away once more. Even the cycles of death fed life here. When an animal perished, its body became food for scavengers, its bones bleached by the sun, and eventually its remains turned to dust that nourished the next generation of plants. Nothing was wasted, even in a land that offered so little. The interior of Pangaea may have seemed like a world apart, but it played a vital role in the planet's story. It influenced global weather, shaped the evolution of reptiles, and preserved countless traces of life in its rocks. The deserts of Pangaea were the planet's memory, silent witnesses to its constant transformation. Scientists studying these ancient deserts today find not just sand and stone, but evidence of a living system, footprints, burrows, plant impressions, and even raindrop marks frozen in time. Each tells a story of how life persisted in places where it should have ended. As the millions of years passed, the Earth began to shift again. The first cracks of continental separation formed far to the west, along what would one day become the Atlantic Ocean. Volcanic activity increased, filling the air with haze and altering global weather patterns once more. Rains slowly began to return to some regions, shrinking the great deserts and creating new grasslands. But for a long and magnificent chapter in Earth's history, the deserts of Pangaea stood as both a challenge and a monument, a vast empire of sand that tested the limits of endurance. The creatures that survived here would carry those lessons forward. When the world changed again, when Pangaea began to break apart, those that had endured the heat and hunger would rise to rule the new continents that followed. In this way, the deserts of Pangaea were not just barren land. They were the crucible of evolution, the proving ground for the future kings of the earth. And from the silence of their endless dunes came the first whispers of what was to come. The age of the dinosaurs in full glory, the rise of giants born from dust and fire. Beneath the vast deserts and forests of Pangaea, the planet's heart was growing restless, deep below the surface. Molten currents of the mantle twisted and churned, carrying heat upward toward the crust. For hundreds of millions of years, these forces had worked in silence, pushing, stretching, and reshaping the land. Now, the balance was beginning to fail. The Earth was preparing for another transformation. The same invisible power that had once united the continents was beginning to pull them apart. Pressure built in the deep layers of rock, forming long cracks across Pangaea's surface. They began as small fissures barely visible, but with time they grew into great scars that stretched for thousands of kilometers. These fractures marked the birth of something new, the beginning of the end for the world's greatest supercontinent. The first rifts appeared quietly, far from the eyes of the creatures that walked above. They opened in places where the crust was weakest, where heat from the mantle pushed hardest against the land. Small earthquakes rippled across the plains. Volcanoes erupted in scattered bursts, releasing smoke and ash into the air. But these were only the early signs. Deep below, a greater force was gathering. As molten rock rose from the mantle, it pressed upward, creating domes in the crust. These domes stretched the land outward, cracking it open in great fractures. Over time, entire valleys began to sink between the rising ridges, forming what scientists now call rift zones. At first, the rifts filled with rivers and lakes. Life continued as before, unaware that these valleys were the beginnings of new oceans. The great rift that would one day split Pangaea apart had begun. In the beginning, it was slow, so slow that no creature alive could sense it. Continents moved at the speed of fingernails growing, yet the forces behind them were stronger than any storm or volcano. In certain regions, like what would one day become the Atlantic margin, the crust began to thin. Magma pushed through the cracks, forming new volcanic fields that burned for centuries. Molten rock spilled over the surface, cooling into black basalt that stretched for miles. Gases rose into the atmosphere, changing its composition once again. These eruptions released massive amounts of carbon dioxide, creating a greenhouse effect that warmed the planet. Temperatures rose, polar ice melted, deserts expanded, and tropical storms became more violent. The world was shifting, both inside and out. As the continents strained against each other, mountain ranges buckled and fractured, entire valleys sank, earthquakes shook the ground with unrelenting force. Rivers changed course, cutting new paths through the fractured land. In some places, massive fault lines tore through forests and plains, leaving behind cliffs that split the horizon. For the creatures of Pangaea, this was an age of instability. Herds of early herbivorous dinosaurs wandered across plains that cracked beneath their feet. Rivers that had flowed for generations suddenly vanished into deep chasms. Lakes drained overnight, swallowed by the shifting crust. The air was thick with dust and volcanic smoke, turning the sun into a pale red orb. But destruction was only one side of the story. Every fracture, every eruption, created new possibilities for life. Fresh volcanic rock, rich in minerals, formed fertile ground for plants to grow. New lakes and wetlands appeared in the rift valleys, attracting animals in search of water. Ecosystems adapted and evolved alongside the planet's changing skin. The Great Rift was both a wound and a birth. In the newly formed valleys, strange environments began to appear. Geysers erupted, spewing boiling water and steam into the air. Mineral springs left colorful streaks across the ground. Underground magma heated entire regions, creating warm basins that supported lush vegetation even during global cooling. These rift zones became havens of life, small pockets of stability in a world of chaos. Scientists studying the rocks of modern continents can still see the fingerprints of these ancient rifts. The red sandstones and basalts that line the eastern coasts of North America and Africa are remnants of that age. They were once the bottom of massive rift valleys, places where Pangaea began to tear itself apart. Each layer of rock tells the story of that slow, violent separation. As the rifts deepened, some began to fill with water from rainfall and underground springs. Over time, these lakes grew larger, eventually connecting to form inland seas. Their waters reflected the smoke of distant volcanoes, their surfaces broken by waves of steam. Along their shores, new forms of life appeared. Fish and amphibians adapted to unstable, mineral-rich waters. Reptiles hunted along the banks, leaving behind fossilized tracks that can still be found today. These rift lakes became the testing grounds of evolution. While the Earth changed around them, the reptiles of the Triassic continued to diversify. Dinosaurs, still relatively small, began to spread across the shifting landscape. They evolved new body structures, better suited for speed and endurance. Their lungs and circulatory systems grew more efficient, allowing them to survive in the increasingly hot and unpredictable climate. Predators grew faster and more intelligent. Herbivores grew larger and more defensive. Evolution was accelerating, driven by the instability of the world itself. Every earthquake, every eruption, Every storm forced life to adapt or die. In many ways, the Great Rift acted as nature's forge, breaking, reshaping, and refining the living world. As the planet's crust continued to stretch, magma rose in greater quantities. In some regions, entire landscapes were consumed by fire. Massive lava flows poured from fissures, burning forests and rivers alike. Volcanic gases spread across the atmosphere, blocking sunlight for months or even years. Temperatures plummeted temporarily before rising again. These cycles of volcanic winter and global warming caused chaos in the ecosystems of Pangaea. Species vanished, replaced by new ones better suited to survive. Yet the rift valleys also became cradles of renewal. As the lava cooled, it released minerals that enriched the soil. Within years, the blackened ground would be covered in green once again. Life was relentless, reclaiming every scar the planet left behind. In the skies above, the early pterosaurs still ruled. They glided over the rift valleys, searching for prey among the lakes and marshes. Their wings caught the updrafts from volcanic heat, allowing them to soar effortlessly for miles. To them, the rifted landscape below must have seemed endless, a labyrinth of canyons, lakes, and smoke. Beneath them, the world was preparing for another step in its evolution. The gradual stretching of the crust would eventually become the birth of the Atlantic Ocean. But during the Triassic, it was only a series of connected valleys, immense, unstable, and full of life. Each tremor, each eruption, was the sound of the Earth slowly pulling itself apart. As millions of years passed, the rift valleys widened. Water from Panthalassa began to seep inland, filling the lowest regions. These shallow seas became new ecosystems, home to corals, ammonites, and early marine reptiles. Coastal forests grew along their edges, filled with insects and small dinosaurs. The supercontinent that had once stood unbroken was beginning to fracture into smaller pieces. Pangea's unity was coming to an end. But even as it broke apart, it continued to shape the destiny of life. The shifting land created new coastlines, new climates, and new pathways for migration. Species that had once shared a single home were slowly separated by growing seas, setting the stage for independent evolution on future continents. This process of division, though violent and destructive, was the reason for Earth's diversity today. Without the Great Rift, without the tearing of Pangaea, there would be no Atlantic Ocean, no separate continents, no variety of climates or species. The world as we know it owes its existence to this slow, inevitable fracture. As the Triassic period drew to a close, the rifting intensified. The air filled with ash once again, and temperatures rose across the planet. The last of the great volcanic eruptions marked the transition to a new age, the Jurassic. By then, the first true dinosaurs had become dominant. They roamed the newly fractured lands in great herds, feeding on the vegetation that grew in the wake of volcanic renewal. Predators grew to match them in strength and size. The Great Rift had set the stage for their empire. And though Pangaea was dying, it was dying beautifully, its final Act 1 of creation. The breaking of the world was not the end, but the beginning of something new. From the cracks of destruction came new continents, new oceans, and a new balance of life. The tension beneath the crust finally began to ease as the first great pieces drifted apart. The sound of the Earth splitting could not be heard by any creature, but its effects were everywhere, in the smoke, in the trembling ground, in the formation of new horizons. The world that had once been one was now becoming many, and from that separation, the modern Earth was born. The Great Rift of Pangaea was not a disaster. It was a transformation. The planet's way of continuing its endless cycle of creation. Every crack, every eruption, every trembling mountain was part of that story. And though the continents drift silently today, moving only inches each year, they are still dancing to the same rhythm that began in that ancient time. The heartbeat of the planet, the slow, eternal pulse of tectonic life, has never stopped. After the Earth began to tear open, a new kind of world emerged. The surface of Pangaea was no longer still. Mountains rose and fell, rivers changed course, and great valleys filled with water. But even more dramatic than the movement of the land was the transformation of the sky. The air itself began to shift, and the planet entered an era of powerful and unpredictable weather, a world ruled by monsoons. The size of Pangaea made its climate unlike anything the Earth has known since. Its enormous landmass disrupted the normal circulation of air and water across the globe. The oceans could no longer balance the planet's temperature. While the coasts remained humid and fertile, the interior grew hot enough to boil the horizon. Every season was extreme. And every year, the sky unleashed chaos upon the land. During the summer months, heat built across Pangaea's vast interior. The sun baked the deserts until the air shimmered and rose, pulling moisture from the surrounding seas. Massive clouds began to form along the coasts, drawn toward the low-pressure heart of the continent. When they finally reached land, they collided with hot air currents and released their fury. It was the birth of the super monsoon, a storm system that dwarfed anything that exists today. These monsoons swept across the edges of Pangaea like living walls of wind and water. Sheets of rain fell for days without pause. Lightning struck with relentless rhythm, splitting trees and setting forests ablaze even in the middle of downpours. Rivers overflowed, drowning valleys and carrying entire forests away in torrents of mud and debris. The sound must have been overwhelming, the crash of thunder rolling across continents, the constant hiss of falling rain, the groan of trees torn from the ground. The air was thick, heavy, alive with the energy of the storm. Yet these rains were both destroyers and creators. Every drop that fell carried minerals and nutrients from the mountains to the plains. As the floods receded, they left behind fertile soil that transformed barren lands into lush new ecosystems. Plants grew with furious speed, covering the ground in a matter of weeks. Insects swarmed in clouds, feeding on the new vegetation. Reptiles emerged from hiding to hunt among the wet ferns and flooded forests. This cycle of destruction and renewal defined the rhythm of Pangaea's monsoon world. Then came winter, the season of silence. As the sun's warmth shifted away, the vast interior of Pangaea cooled rapidly. The monsoon winds reversed direction. Instead of pulling moist air inward, the cold, dry air from the deserts blew outward toward the coasts. The once green plains turned to dust. Rivers shrank to thin lines. The skies cleared, leaving nothing but the pale light of the sun and the whisper of the wind. Creatures that had thrived in the wet season now faced hunger and thirst. Many migrated toward the coasts, following the receding water. Others hibernated, retreating into burrows or caves to wait for the storms to return. Life on Pangaea had learned to live by the seasons, not gentle changes, but extremes that decided life and death every few months. The monsoon cycle carved its mark deep into the land. Enormous river systems, fed by seasonal floods, cut through the continent. Some rivers stretched for thousands of kilometers, connecting inland deserts to the coasts. When the rains came, they roared with unstoppable power. When they left, only cracked earth remained. Fossils found today show clear evidence of this pattern, sediment layers alternating between flood deposits and dry, wind-blown sands. It was a geological heartbeat, a record of the planet's seasonal rhythm. Scientists believe that the strength of Pangaea's monsoons came from its size and position. Most of the supercontinent lay near the equator, where the sun's energy was most intense. As hot air rose from the deserts, it created powerful convection currents that pulled in moist ocean air from every direction. This process created massive storms that could cover entire regions at once. In some coastal areas, these rains turned the land into vast swamps and wetlands. The vegetation grew thick, and the air was heavy with the scent of rot and life. Amphibians returned to these places each year to breed, filling the night with echoes of their calls. Reptiles, meanwhile, stalked the shallows, preying on fish and smaller creatures that flourished in the floods. Inland, where the monsoon's reach began to fade, the rains came less often. The result was a shifting boundary between forest and desert, a line that moved back and forth with the seasons. Plants and animals that lived here were forced to adapt to both wet and dry conditions. Some species developed the ability to store water, while others migrated along predictable routes following the rain. The constant shifting of ecosystems drove evolution to new speeds. Animals that could adapt quickly to the changing climate flourished, while others perished. As the Triassic world progressed, dinosaurs began to take full advantage of this new environment. Herbivorous dinosaurs followed the monsoon rains across the plains, feeding on the fresh vegetation that grew after each flood. Their migrations were vast, stretching for hundreds of kilometers. Predators followed closely behind, using the chaos of the storms as cover for ambushes. The monsoon world became a stage of endless movement. Nothing stayed still. Not the rivers, not the land, not the sky. Every creature, from the smallest insect to the largest reptile, lived within this rhythm. The rain season was life's great opportunity. New plants sprouted overnight, insects hatched by the millions, and young reptiles emerged from their eggs into a world overflowing with food. For a few short months, everything grew, bred, and multiplied. But when the dry season came, the world withered. Waterholes turned to dust, leaves fell, and carcasses littered the plains. Predators starved, herbivores collapsed from thirst, and even the plants fell silent beneath the unrelenting heat. Yet, when the monsoons returned, the cycle began again. These extreme patterns of survival forced species to evolve remarkable adaptations. Some dinosaurs developed nesting strategies that synchronized with the coming rains, ensuring their hatchlings emerged when food was most abundant. Others evolved larger lungs and more efficient metabolisms to handle the thin, hot air of the dry season. Plants, too, became more resilient. Ferns and cycads grew thick, waxy coatings to retain moisture. Seeds evolved to remain dormant through the droughts, waiting patiently for the return of rain. This evolutionary dance between life and climate shaped the Triassic world into something both savage and beautiful. From a distance, Pangaea would have looked alive, its surface constantly changing color with the seasons. Green forests along the coastlines darkened after the rains, while the deserts glowed red beneath the sun. The boundary between them shifted endlessly, a breathing planet painted by weather. The sky was its canvas. Each monsoon brought not just water, but spectacle. Lightning storms flashed across the horizon like rivers of fire. Thunder rolled across the land, echoing through valleys and mountains. The air smelled of ozone and soil, a scent of renewal mixed with decay. For the creatures that lived beneath these storms, this was normal. The chaos of the atmosphere was as much a part of life as hunger or fear. Evolution had not just adapted to the storms, it had learned to depend on them. The monsoon world also influenced the shape of the land itself. Constant erosion carved deep canyons and sculpted new valleys. The rivers carried sediments to the coasts, building deltas and forming new islands along the edges of Pangaea. These shifting landscapes created endless opportunities for life to spread and evolve. But the same forces that brought fertility also carried danger. Massive floods buried forests, suffocating everything beneath layers of mud. Volcanic eruptions, triggered by the planet's ongoing tectonic tension, added to the devastation. Ash mixed with rain, turning to acid that poisoned lakes and rivers. Entire regions vanished beneath layers of sediment. Yet, once again, life found a way. As new land rose from the destruction, it was quickly reclaimed by green. This resilience was the defining trait of Pangaea's ecosystems, an endless ability to start over. The monsoon world was Earth's great experiment in renewal. It taught life how to move with the planet, not against it, how to endure destruction and use it to grow stronger. This was evolution through chaos, adaptation through instability. The lessons learned in these storms would echo through time. Millions of years later, when the continents finally drifted apart, the descendants of these Triassic survivors would inherit the Earth. They carried within them the instincts born in the monsoon world, the ability to endure, to migrate, to rebuild. The Earth itself was alive with this rhythm. It breathed through its seasons, inhaling rain and exhaling dust. The sound of thunder was its heartbeat. And as the storms raged over the vast, splitting supercontinent, the planet was quietly reshaping its destiny. The rains would not last forever. As the tectonic rifts deepened and the first true oceans began to form, the pattern of the monsoons would slowly begin to fade. But for millions of years, they ruled the world, a reminder that even the most violent forces of nature could also be the source of life. The monsoon world was both chaos and creation, fury and fertility, destruction and rebirth. And through it all, the creatures of Pangaea learned to survive not by resisting the storm, but by becoming part of it. Beneath the roaring monsoons and the trembling continents, another world thrived, a world hidden below the surface of Panthalassa, the great ocean that surrounded Pangaea. While storms raged above, the seas below were alive with creatures unlike anything that would ever exist again. This was a planet ruled by water, and within that water, empires of life had risen and fallen long before the first dinosaurs walked the Earth. The oceans of the Triassic were vast, deep, and full of mystery. They covered nearly 70% of the planet. And though Pangaea's landmass seemed eternal, it was the ocean that truly defined Earth's heartbeat. Every current, every tide, every migration of plankton and predator shaped the climate and the balance of life on a global scale. It was in these waters that evolution staged its grandest comeback after the Permian extinction. The end of the Permian had destroyed almost all marine life. Coral reefs disappeared, ammonites and trilobites were nearly wiped out, and the seafloor became a graveyard of silence. For a brief time, the oceans turned toxic, thick with carbon dioxide and depleted of oxygen. The waters were still, lifeless and dark. But as the Triassic began, sunlight returned. Volcanic activity slowed, temperatures stabilized, and the chemical balance of the oceans began to heal. Within a few million years, life surged back with astonishing strength. Plankton, the invisible architects of the sea, were the first to return. These microscopic organisms filled the surface waters, transforming sunlight into energy and oxygen. They became the foundation upon which everything else depended. From plankton came the rebirth of the marine food chain. Tiny fish followed, then larger predators. Coral reefs began to rise again in shallow, warm waters near the edges of Pangaea. They grew in strange, intricate patterns, forming underwater forests of stone and colour. Within them lived creatures of every shape and form: sponges, mollusks, crustaceans, and schools of darting fish. The ocean was alive once more, and its empire was vast. Among the first to reclaim dominance were the ammonites, spiral-shelled relatives of modern squids. They floated through the open seas like living jewels. Their shells coiled in perfect geometry, marked by intricate ridges that shimmered in the light. They were hunters and scavengers, feeding on smaller creatures and plankton. With each generation, they evolved new shell shapes and survival strategies, adapting to every corner of the ocean. For millions of years, ammonites ruled the waves, drifting gracefully through the shallows and the deep alike. Their presence was so vast that their fossils now mark time itself. Scientists measure the ages of rocks by the types of ammonites they contain. But the true masters of the Triassic seas were the marine reptiles. After the Great Extinction, some land-dwelling reptiles ventured back into the water, searching for food in the recovering oceans. Over generations, they adapted to this new environment, transforming into creatures perfectly suited for life beneath the waves. The first of these were the nothosaurs. They were sleek, long-necked reptiles that glided through the water with flipper-like limbs. Their bodies were built for both land and sea. They could crawl onto the beaches to rest or lay eggs, but in the water they were graceful hunters. Their diet consisted mostly of fish and cephalopods, which they caught with sharp, conical teeth. Over time, some nothosaurs became fully aquatic, evolving into the ichthyosaurs, perhaps the most remarkable creatures of their time. Ichthyosaurs looked like dolphins, but they were reptiles, not mammals. Their bodies were streamlined, built for speed. Their large eyes allowed them to hunt in the dim light of deep water, and their tails, shaped like a crescent moon, could propel them at incredible speeds. They were warm-blooded hunters in a cold-blooded world. In the open ocean, ichthyosaurs hunted in packs, chasing schools of fish and ammonites across the depths. They gave birth to live young in the water, an extraordinary adaptation that freed them from the need to return to land. In every sense, they had become creatures of the sea. The reign of the ichthyosaurs marked a new chapter in evolution. They represented mastery, intelligence, and adaptability, the ocean's perfect design. Beneath them, the coral reefs and shallow bays were home to smaller, stranger species. Coelacanths, ancient fish that had survived since before Pangaea's formation, still swam in deep waters, their fins moving in a slow, rhythmic pattern like living fossils. In the coastal regions, armored fish grazed on sea plants, while rays and early sharks glided silently over the sand. Crinoids, relatives of sea stars, waved their delicate arms from the sea floor, filtering nutrients from the water everywhere. Life pulsed in balance. But the ocean was not peaceful. It was a realm of endless struggle and competition. Predators hunted constantly. Some ichthyosaurs specialized in deep-sea ambushes, while others grew enormous, capable of devouring prey their own size. Smaller reptiles, like the placodonts, evolved heavy shells to protect themselves, resembling the later turtles that would inherit their design. The ocean's food chain was a perfect equilibrium of creation and destruction. And even deeper, Beyond the reach of light, another world existed here. In the black depths of Panthalassa, the temperature dropped close to freezing. No sunlight ever penetrated. Yet, even here, life found a way. Gigantic squid-like creatures drifted through the dark, blind fish, hunted by sensing vibrations in the water. Worms and crustaceans lived around hydrothermal vents, feeding on chemical energy released from the Earth's crust. These vents glowed faintly in the darkness, creating small oases of light and heat amid the abyss. The deep ocean was a world almost untouched by time. It changed slowly, silently, watching the drama of the surface from below. The creatures of the sea shaped the Earth as much as the continents did. Their shells and skeletons fell to the ocean floor, forming layers of limestone that would one day rise into mountains. Coral reefs grew and died, leaving behind massive carbonate structures that now form the foundations of islands and cliffs around the world. Every ripple of Panthalassa left a permanent mark on the planet. The relationship between land and sea was constant and intimate. Volcanic activity beneath the ocean floor created new land, while erosion from rivers carried minerals and nutrients back to the sea. This exchange fueled evolution in both realms, connecting the fate of Pangea's deserts and forests with the depths of Panthalassa. Storms above the water sent waves crashing against the coasts, breaking coral and reshaping reefs. Each storm was both destruction and renewal, scattering life across new regions. Some species used these violent events to migrate, carried by drifting debris and currents. Others hid, surviving in the calm below, while chaos reigned at the surface. Scientists studying fossils from this time have discovered entire layers of marine sediment filled with the remains of creatures killed during ancient storms, evidence of nature's power even beneath the sea. The Triassic oceans were also the birthplace of some of the most extraordinary evolutionary experiments in shallow lagoons. Small reptiles began to develop paddle-like limbs and longer tails. They would eventually evolve into plesiosaurs, though their true dominance would not come until later. These experiments of nature were the first steps toward the giants of the Jurassic seas. By the late Triassic, the underwater empires had reached their peak. Ichthyosaurs dominated the open ocean, nothosaurs ruled the coastal shallows, and ammonites filled every niche in between. Life was flourishing in every layer of the sea. But beneath this thriving world, tension still brewed. The tectonic shifts that had begun to tear Pangaea apart were also reshaping the ocean floor. Underwater ridges spread, creating new crust. Volcanic activity intensified, releasing carbon dioxide and methane into the water. These changes began to alter the chemistry of the oceans once again. Temperatures rose, oxygen levels dropped, and slowly the balance that life had fought so hard to rebuild began to tip once more. For the creatures of Panthalassa, the signs were subtle: a shift in current, a change in water color, a few species vanishing from the reefs. But these small changes were warnings of another global transformation on the horizon. The underwater empires had risen from extinction before, and they would face it again. Still, for millions of years, they ruled with unmatched beauty and power. Beneath the waves, sunlight filtered through blue water, illuminating forests of coral and swarms of silver fish. Ichthyosaurs glided effortlessly through the deep, their sleek bodies cutting through the dark like arrows of light. Ammonites spiraled upward, their shells reflecting flashes of gold and bronze. It was a world that seemed eternal, untouched by the violence of the land above. But nothing on Earth lasts forever. The same restless energy that had forged Pangaea and filled its oceans with life would soon begin another cycle of destruction. The seas would rise, the continents would shift, and the creatures that once ruled the water would vanish into the fossil record. Yet their legacy would remain. The shells of ammonites, the bones of ichthyosaurs, and the coral reefs they built still sleep within the rock of modern Earth. Mountains once formed from the ocean's floor now hold their fossils like memories of an age long past. The underwater empires of the Triassic were not just worlds beneath the waves, they were the architects of our planet's balance. They transformed the oceans, the atmosphere, and even the continents themselves. And though their reign ended long ago, their story still echoes in every tide, every coral reef, and every ripple of the sea. For life, like the ocean, never truly ends, it only changes form. And from the depths of Panthalassa, the next chapter of evolution was already stirring. The world of Pangaea was alive and growing stronger, but beneath its beauty, something deeper was happening, an invisible transformation that would change the planet forever. It began with the smallest things. In the oceans, trillions of microscopic organisms drifted in the sunlight, turning water and carbon dioxide into oxygen. On land, forests stretched across the coasts and plains, their leaves breathing in the air of an older world and exhaling something new. The balance of life was shifting. The Earth was slowly filling its lungs. This was the oxygen revolution. For billions of years, oxygen had existed on Earth, but never in such abundance. During the Triassic period, as the supercontinent of Pangaea stabilized after its endless turmoil, the rise of plant life, both on land and in the sea, ignited an atmospheric transformation. The ancient forests that lined Pangaea's coasts became vast machines of breath. Every leaf, every blade of fern absorbed carbon dioxide from the air and released oxygen in its place. Across the surface of the planet, this invisible gas began to accumulate. In the shallow seas, algae and plankton did the same, creating an underwater bloom of life. Together, they turned sunlight into chemistry, fueling the greatest environmental change since the birth of the continents themselves. At first, the difference was subtle. The air became a little clearer, the sky a little brighter. The colors of the world deepened greens more vivid, blues more intense. But as oxygen levels continued to rise, the change became profound. The creatures of the Triassic began to grow larger. Insects, freed from the limits of thin air, expanded to enormous sizes. Dragonflies with wingspans wider than a human arm soared over the forests. Millipedes longer than a person slithered across the damp soil. Every breath carried more energy, and evolution took full advantage. Reptiles, too, benefited from this atmospheric abundance. Their blood carried oxygen more efficiently, their muscles grew stronger, and their endurance increased. The new air allowed them to hunt longer, move farther, and dominate more territory. The oxygen revolution gave rise to giants. In the oceans, this transformation was just as dramatic. The rich oxygen supply fueled the growth of massive marine predators. Ichthyosaurs grew larger, their bodies more powerful, capable of long, deep dives. New species of ammonites developed complex shells and advanced buoyancy systems, using the enriched oxygen to sustain more active lifestyles. The coral reefs flourished, growing faster and taller than ever before. They became towering underwater fortresses, layered with life in every color. Oxygen was the unseen architect behind all of it. As plants and algae continued their silent labor, the balance of gases in the atmosphere shifted. For the first time, oxygen made up a significant portion of the air, enough to support complex ecosystems across the planet. The Earth's climate stabilized, temperatures moderated, and the cycles of carbon and life intertwined in a self-sustaining rhythm. The forests of Pangaea became the lungs of the planet. They covered the coasts in endless green, stretching for thousands of kilometers. In some regions, conifer forests replaced older fern-covered swamps, creating new ecosystems filled with insects, amphibians, and reptiles. Sunlight filtered through the dense canopy, casting a green glow on the forest floor. Vines crawled up the trunks of ancient trees, while fungi fed on fallen leaves and decomposing wood, recycling nutrients back into the soil. The air was heavy with the scent of earth, rain, and resin. Every breath carried life. Beneath these forests, small mammals began to evolve, tiny shrew-like creatures that scurried through the undergrowth. They were insignificant compared to the reptiles that ruled the land, but their warm-blooded hearts and high metabolisms gave them a quiet advantage. They could move at night, surviving where others could not. This was evolution's subtle preparation for a distant future. The oxygen-rich world allowed life to diversify in new ways. Metabolisms became faster, movements quicker, senses sharper. For the first time, animals began to develop sustained activity rather than short bursts of motion. Hunting became endurance, not ambush. Migration became possible over longer distances. The very nature of life changed. But as with every revolution on Earth, there was a cost. Oxygen is both life-giving and dangerous. Too much of it makes the world burn easily. And in this new, oxygen-rich environment, fire became a constant threat. Lightning storms sparked wildfires that swept through forests for weeks at a time. The dense, oxygen-filled air fed the flames, making them burn hotter and faster than ever before. Entire regions of Pangaea would ignite, turning the night sky into a red haze. The smoke would rise into the atmosphere, blocking sunlight and altering the global temperature. These fires destroyed vast areas of vegetation, but they also returned nutrients to the soil, preparing it for the next generation of growth. Even destruction became part of the cycle. The Earth was learning balance through chaos. Scientists can still find evidence of these ancient fires in the rock's layers of charcoal and ash buried deep within fossilized soil. Each blackened layer tells the story of a world that burned and regrew over and over again. In the aftermath of the fires, the forests returned quickly. Plants evolved fire-resistant bark and the ability to regrow from roots after being scorched. Seeds developed hard shells that could survive heat. Fire, once an enemy, became part of the natural order. The oxygen revolution was more than an atmospheric change. It was a complete reprogramming of life's possibilities. Creatures began to exploit the abundance in new ways. Amphibians that once relied on wet habitats now ventured farther inland. Reptiles colonized deserts and mountains. Insects developed complex wings, capable of flight patterns that seemed impossible in thinner air. The diversity of life exploded across Pangaea. The rivers and lakes that had once been silent after the great extinction now buzzed with activity. Fish darted through clear waters, amphibians croaked from the banks, and insects swarmed in the air above. Every part of the planet was filled with movement and sound. Even the oceans reflected this transformation. Higher oxygen levels supported new ecosystems in the deep. Predators grew faster and more efficient, prey evolved better defenses, and coral reefs became entire cities of interdependent life. In this golden age of oxygen, life was more dynamic than ever before. The planet had rebuilt itself, not through dominance, but through cooperation between the smallest and largest forms of life. From algae to reptiles, from plankton to trees, every organism played a role in maintaining the delicate balance of air and water. The atmosphere itself became a living system, constantly breathing, constantly adjusting. When plant life expanded, oxygen levels rose. When wildfires or volcanic eruptions reduced vegetation, oxygen fell. The planet had achieved a self-regulating cycle, one that would define Earth for millions of years to come. And yet, even this balance was fragile. Beneath the surface, the planet's tectonic energy never stopped moving. The cracks in Pangaea deepened, widening into new seas. Volcanoes continued to erupt along the rifts, pouring gases into the air. Each eruption released carbon dioxide, challenging the new oxygen balance. This constant push and pull between creation and destruction kept the planet in motion. But for now, life flourished. The oxygen revolution had given the world new strength. It allowed creatures to grow bigger, move faster, and evolve more complex behaviors. It created forests that covered continents and oceans filled with giants. The world was alive in a way it had never been before. The sky was bluer, the clouds brighter, and the sunsets deeper in color, tinted by the oxygen-rich air. On clear days, the horizon shimmered with life, flocks of flying reptiles gliding above forests, herds of dinosaurs moving across open plains, and the distant sound of thunder rolling over the sea. This was the Earth at its most vibrant, a planet pulsing with energy, its atmosphere alive and balanced. It was also a planet on the edge of change, because every revolution, no matter how beautiful, carries the seeds of its own undoing. As oxygen fueled life's growth, it also fueled fire, heat, and instability. Volcanic eruptions and monsoon storms intensified. The same air that gave the planet strength would soon make it volatile. The oxygen revolution was not the end of the story, it was the beginning of a new kind of fragility. But for now, the planet exhaled. It breathed deeply for the first time, filling its skies and oceans with energy. The world was whole, alive, and magnificent. And in the forests of Pangaea, under the warm Triassic sun, life thrived in its golden age, unaware that the balance it had created would not last forever. For millions of years, the world had thrived under balance. The forests of Pangaea breathed oxygen into the skies. The oceans shimmered with life, and the atmosphere carried a delicate rhythm of creation and renewal. But beneath the crust, something powerful and ancient was awakening. The same molten energy that had once united the continents was beginning to rise again, restless and unstoppable. Pressure built deep within the mantle, gathering in vast chambers of magma. It was only a matter of time before the Earth exhaled, not with breath, but with fire. And when it did, the balance shattered. The first signs came quietly. Tremors rippled through the crust. Subtle at first, barely noticeable. The rivers that had flowed for centuries began to shift their paths. Lakes bubbled with strange gases. Animals grew uneasy, their instincts whispering of danger. Then the world erupted. Massive fissures tore open across the land, releasing oceans of molten rock. Volcanoes that had slept for ages roared back to life. Columns of fire and smoke reached kilometers into the sky. Rivers of lava poured through forests, igniting everything in their path. The air filled with ash, so thick that day turned to night. It was one of the most violent volcanic episodes in Earth's history. Scientists believe these eruptions were part of a cataclysmic event known today as the Central Atlantic Magmatic Province. It began roughly 201 million years ago as Pangaea's crust fractured along its central rift. What followed was not a single eruption, but millions of years of fire waves of lava that spread across continents layer upon layer, reshaping the planet. The heat was unimaginable. Entire regions became seas of fire. The forests that had fed the oxygen revolution burned to ash. Carbon dioxide and methane flooded the atmosphere, trapping heat and altering the climate. For a time, the planet was engulfed in flames. As the lava cooled, it released vast amounts of sulfur dioxide into the air. These gases reacted with water vapor, forming aerosols that reflected sunlight away from the Earth. Temperatures plummeted. The heat of the firestorms gave way to a long, cold silence. The world entered a volcanic winter. For years, sunlight struggled to reach the surface. The skies turned grey, and acid rain fell across the land. Oceans cooled, their surface waters turning still and lifeless. Plant life withered, unable to photosynthesize. The great oxygen cycle that had once sustained the planet began to falter. With the forests gone and photosynthesis reduced, oxygen levels dropped sharply. Many creatures that had grown large and dependent on the rich air could no longer survive. The once flourishing ecosystems of the Triassic began to collapse. Insects fell from the skies. Herbivorous dinosaurs starved as vegetation vanished. Predators, deprived of prey, turned on each other or perished in the cold. It was as if the planet had stopped breathing. Across the coasts, volcanic ash settled into the oceans, smothering coral reefs and poisoning marine life. Acidification from the gases dissolved the shells of ammonites and plankton. Oxygen levels in the water fell, creating vast dead zones where nothing could live. The underwater empires that had ruled Panthalassa for millions of years began to crumble. On land, the temperature swings were brutal. Summers became scorching, winters freezing. Storms ripped across continents. Lightning ignited the forests that had somehow escaped the first wave of destruction. The fires spread through the dry air, feeding on the oxygen that remained. Entire regions burned until nothing but blackened stone was left. These were the global firestorms, vast planet-wide infernos that consumed everything. Scientists studying rock layers from this period find charcoal and soot deposits scattered across multiple continents, proof that Earth had been engulfed by flames. Some of these layers stretch for hundreds of meters, representing centuries of burning. The atmosphere, once rich and clean, became thick and heavy with smoke. Sunlight filtered through a haze that turned the sky red. It was a world of twilight, where the sun was only a pale ember behind curtains of ash. Life, once abundant, now clung to the edges of existence. The volcanic winters lasted for years, perhaps decades. Temperatures fell by as much as 10 degrees globally. Glaciers advanced from the poles. Oceans cooled and sea levels dropped. The contrast between the burning ground and the frozen air created violent winds that swept across the continents. In this chaos, extinction took its toll. More than 75% of species vanished in what is now known as the Triassic-Jurassic extinction event. Entire lineages of reptiles, amphibians, and marine creatures disappeared forever. But not all life died. As the eruptions slowed and the air began to clear, survivors emerged from the ashes. Small dinosaurs, with lightweight bodies and efficient lungs, endured where others failed. Their adaptability allowed them to thrive in the fluctuating climate. Some mammals also survived, tiny, warm-blooded creatures that hid underground or in the shelter of forests. Their size and flexibility gave them an edge in the ruined world. In the oceans, certain species of ichthyosaurs and ammonites managed to persist, adapting to the colder, low-oxygen waters. Plankton populations eventually rebounded, restarting the cycle of life from the bottom up. The volcanic winters began to fade, and the planet slowly warmed again. The air cleared, the sun returned. Rain washed the ash from the forests, feeding new growth. The land, blackened and silent, began to turn green once more. From destruction came renewal again. The forests that returned were different. The species that had dominated the Triassic were gone, replaced by hardier plants that could survive drought, fire and frost. Ferns and conifers reclaimed the land first, spreading rapidly across the nutrient-rich volcanic soil. Within a few thousand years, the coasts of Pangaea were once again covered in green. The oxygen cycle began anew. It was as if the planet had been reborn, scarred, but alive. The survivors inherited a world transformed. The dominance of reptiles continued, but the balance of power had shifted. The smaller, more adaptable dinosaurs that had weathered the storm now had no rivals left to challenge them. With the extinction of older reptile groups, the path was clear for their rise. This was the dawn of the Jurassic, and from the ashes of the Triassic's firestorms, the age of giants would emerge. The volcanic events that nearly destroyed life also reshaped the planet's geography. As lava cooled along the Great Rift, new land formed between the splitting continents. The central fissures of Pangaea widened into seas. What had once been connected began to drift apart, slowly and silently. These new coastlines would become the cradles of evolution for the next era. But the memory of fire remained. The rocks of this time still carry the fingerprints of those cataclysms. Layers of basalt stretching across continents, frozen rivers of lava that now form mountains and plateaus. Trapped within them are the gases, minerals and carbon that record Earth's greatest fever. They remind us that every cycle of creation comes at a cost. The oxygen revolution had given life its breath. The volcanic winters had taken it away. The planet had burned, frozen, and burned again. And yet, each time, it had rebuilt itself, stronger and more complex. The story of Earth was not one of destruction, but of endurance. Beneath the surface, the mantle still pulsed with heat. The same restless energy that caused the firestorms continued to shape the continents, pushing them apart, giving birth to the world we know. The creatures that survived carried the memory of fire in their evolution. They became faster, smarter, more resilient. They learned to adapt to scarcity and chaos. The foundations of modern ecosystems were forged in the crucible of those volcanic winters. And above it all, the planet continued to breathe. Each eruption, each fire, each renewal, a part of its endless cycle. For Earth has never been a place of stillness. It is alive, ancient, and ever-changing. It destroys only to create again. The volcanic winters and firestorms of Pangaea were not the end of life, they were its transformation. And as the world cooled and the skies cleared, the survivors stepped into the light of a new dawn. The age of dinosaurs had begun. The world that rose from the ashes of fire was no longer the same. Pangaea, once mighty and unbroken, began to tremble under its own weight. The scars left by volcanic fury were not just wounds, they were fault lines, deep cracks that reached into the planet's heart. Beneath the green forests and new rivers, the crust was splitting apart. The breakup of Pangaea had begun. It started slowly, as all great changes do. No creature alive could have seen it happening. Mountains rose where once there were plains. Rivers shifted courses without warning. The ground groaned with distant thunder. From the deserts of the interior to the coastlines of the Panthalassa Ocean, the land was changing beneath the feet of its inhabitants. The forces that tore the supercontinent apart came from deep within the Earth. Convection currents in the mantle flowing like slow rivers of fire pushed against the crust. The plates of the planet were restless, carrying the heat of millions of years beneath them. When that heat rose, it weakened the bonds that held the continents together. For hundreds of millions of years, these plates had been drifting as one giant landmass. But now, the balance had shifted. As the crust stretched, new cracks opened, some hundreds of kilometers long. Molten rock rose through them, forming lines of volcanoes that burned across the landscape. These fiery scars marked the birth of new oceanic crust, the very first foundations of the Atlantic Ocean. At first, these rifts were nothing more than valleys filled with lakes and rivers. But as the Earth continued to pull itself apart, the valleys deepened and the seas began to flow in. The waters of Panthalassa crept slowly into the cracks, transforming dry land into shallow bays. What had once been a single continent was now becoming two. Scientists call them Laurasia in the north and Gondwana in the south. Together, they were still massive, but the unity of Pangaea was broken forever. The world entered a time of transition, of continents drifting and seas being born. As the Great Rift widened, the planet's climate began to shift once more. Volcanic activity along the rift zones released enormous amounts of carbon dioxide, warming the atmosphere. The cool, harsh climate of the volcanic winters gave way to a greenhouse world. Temperatures climbed, ice melted, and the air grew humid again. Monsoons returned, heavier than before. Jungles spread across the coasts. Inland deserts shrank beneath the rains. The Earth had entered a new age, the Jurassic. It was a world of heat, humidity, and life. The dinosaurs, survivors of fire and famine, thrived in this new environment. They grew larger, faster, and more diverse. Herbivores roamed in massive herds, shaking the ground beneath their feet. Predators evolved to match them, sleek and intelligent hunters that ruled the plains and forests. The breakup of Pangaea, though destructive, had created a planet of opportunity. As the continents drifted apart, new coastlines appeared, fresh habitats filled with rivers, swamps, and deltas. These borderlands between land and sea became breeding grounds for evolution. Isolated species began to evolve in different directions, each adapting to its own environment. This separation was the spark that would ignite the diversity of life we see today. But the process was slow and violent. Earthquakes shook the rift valleys constantly. Molten rock poured from fissures, spreading across the ground like rivers of fire. In some regions, entire forests were buried beneath lava, only to be revealed millions of years later as petrified stone. The air was thick with ash, but it carried the scent of renewal. Every eruption released minerals that enriched the soil. Within years, vegetation returned, feeding insects and herbivores once more. The planet had mastered the cycle of destruction and rebirth. The newly forming seas between Laurasia and Gondwana became corridors of change. Shallow, warm, and rich with nutrients, they were teeming with life. Coral reefs grew along their edges, sheltering countless marine creatures. Ammonites, having survived the extinction, flourished again. Ichthyosaurs and plesiosaurs ruled the water, hunting with precision and grace. The breakup of Pangaea did not just reshape the land, it reshaped the oceans too. Currents that once circled a single massive continent now split into complex systems. Warm water flowed into new seas, while cold water sank into the depths. These new ocean patterns altered weather across the planet, creating regional climates for the first time in millions of years. The world was learning to breathe differently. In the north, Laurasia drifted slowly toward the poles, creating cooler climates and dense forests of conifers and cycads. In the south, Gondwana remained warmer, a land of lush jungles and swampy lowlands. Between them, a growing ocean sparkled beneath the sunlight, a newborn body of water that would one day become the Atlantic, but the process of separation was relentless. As the rift widened, magma continued to rise, creating mountain ranges along the edges of both continents. Volcanic islands formed in the sea, born from the constant pressure of the planet's heart. Over time, these islands would drift apart as the ocean floor expanded. The sound of earth breaking was everywhere, deep rumbling from below, the roar of eruptions, the crash of waves against newborn cliffs. To the creatures living through it, this was simply the world they knew. Dinosaurs grazed near the shores of the new seas, unaware that they stood on land that had once been part of another continent. In the oceans, marine reptiles glided through the widening channels, following schools of fish that migrated with the changing currents. The breakup of Pangaea was not a single event, but a slow and continuous process, a geological heartbeat that lasted tens of millions of years. Each movement of the plates changed the planet's shape. Each eruption redrew the map of the world. By the middle of the Jurassic, the transformation was undeniable. Laurasia and Gondwana were now separated by a vast stretch of oceanic crust. Panthalassa still encircled the planet, but it was no longer the single dominant sea. Smaller bodies of water, the Tethys and the Proto-Atlantic, had begun to divide it. The continents were no longer one, and life would never be the same again. This fragmentation of the world brought isolation, and isolation meant evolution. Creatures cut off from one another began to follow separate paths. Dinosaurs in the north evolved differently from those in the south. Climates diverged, shaping new forms and behaviors. In Laurasia, predatory dinosaurs like megalosaurs and allosaurs emerged, ruling the open plains and dense forests. In Gondwana, massive herbivores like brachiosaurs and sauropods grew to immense sizes, feeding on towering trees. The seas, too, became laboratories of evolution. Plesiosaurs and ichthyosaurs developed new hunting techniques and body forms. Coral reefs became more complex, giving rise to new species of fish and invertebrates. The planet was alive with innovation. But beneath all this beauty, the slow drift continued. Continents moved apart by only a few centimeters each year, yet the effects were enormous. Every centimeter changed the shape of the oceans, the flow of the winds, the pattern of the seasons. Earth itself was learning how to move. The breakup of Pangaea was not just geological, it was emotional, in the way the planet seemed to pull away from its own unity. The single land that had held everything together for hundreds of millions of years was dissolving, its pieces drifting into their separate destinies. The silence of the ancient deserts was replaced by the sound of waves crashing against new shores. The endless horizon of Pangaea's interior had been broken by water, by life, by movement. And from that movement came diversity. The same event that destroyed the unity of the supercontinent created the variety of worlds that now exist. Without the breakup, there would be no Africa, no Europe, no Asia or America. There would be no isolation, no evolution into distinct ecosystems, no richness of species. The death of Pangaea was the birth of the modern Earth. Scientists can still trace the scars of this separation. The matching coastlines of Africa and South America, the identical fossils found on both sides of the Atlantic, all are evidence of a world that was once whole. Beneath the oceans, the mid-Atlantic ridge still burns with the same fire that tore Pangaea apart. Lava continues to rise there today, pushing the continents farther apart, inch by inch. The breakup never truly ended, it only slowed. And though the dinosaurs of that age never knew it, they were walking across a planet in motion. Every footstep, every echo, every call across the forests was carried on a world that was drifting, alive and changing. The story of Pangaea was ending, but the story of the world we know was just beginning. The breakup of the supercontinent was not a tragedy. It was evolution on a planetary scale. It was the Earth becoming itself. The age of unity was gone. The world had been broken apart, reshaped by fire and pressure, and in its place rose a planet that was younger, warmer, and filled with life. The single landmass that had once stretched from pole to pole now drifted into pieces, each carrying its own destiny. Oceans widened, climates diversified, and life adapted to the new order of the Earth. This was the rise of the New World. It was an age of rebirth, of endless green and motion. The Jurassic period had arrived. After the chaos of fire and famine, the planet had settled into a long, humid calm. The air was thick and warm. Rain fell in constant rhythm. Forests returned, growing larger and denser than ever before. Conifers, cycads, and ferns spread across continents, covering the land in green oceans of leaves. Sunlight filtered through the canopies in gold streams. The air smelled of resin, moss, and rain. Insects buzzed through the humid air, their wings flashing like glass. Frogs croaked from the undergrowth, and rivers glimmered between roots as wide as tree trunks. The Earth had remade itself into paradise. This was the world that the dinosaurs inherited. They were no longer the small, desperate survivors of a dying world. Now, they were the rulers of an empire. The new oxygen-rich atmosphere and fertile land gave them everything they needed to grow, and they did. On the open plains of the northern continents, herds of sauropods towering, long-necked giants moved across the land like living mountains. Each footstep sent tremors through the ground. They fed on treetops that no other creature could reach, stripping branches clean in sweeping arcs of motion. Their necks moved like cranes, and their tails cracked through the air like whips. Around them, smaller dinosaurs darted through the ferns, agile hunters and scavengers that thrived in the shadows of the giants. The forests echoed with the deep, rhythmic calls of these creatures, a chorus of life that carried for miles. The balance of power in the new world was perfect. For every predator there was prey, for every forest a desert, for every ocean a river that carried life between them. The seas were no less alive. As the continents separated, the oceans grew warm and shallow. Sunlight reached the depths, allowing coral reefs to flourish again. These reefs became underwater cities, alive with color and motion. Ammonites spiraled gracefully through the water, their shells glinting in the light. Ichthyosaurs, the sleek hunters of the open sea, glided between schools of fish, moving with the precision of arrows. Plesiosaurs, with long necks and sharp teeth, lurked near the coasts, waiting to strike. The oceans of the Jurassic were worlds of motion and light, full of balance and danger. Above the water, new rulers appeared in the sky. The pterosaurs, those ancient pioneers of flight, had grown larger and more diverse. Their wings stretched wide, catching the warm thermals rising from the forests and coasts. They glided effortlessly for hours, their shadows crossing rivers and cliffs. Some hunted fish, diving into the sea and emerging with shimmering prey in their jaws. Others lived along the cliffs, nesting in colonies that echoed with cries carried by the wind. For the first time, the sky belonged to life. It was a planet without silence. In the south, Gondwana's landscapes were vast and wild dense jungles, swampy lowlands, and massive deltas where rivers met the sea. Here, enormous brachiosaurs towered over forests, feeding high above the canopy. Smaller herbivores grazed in the open clearings, while predators watched from the shadows. One of these hunters, Allosaurus, reigned as king. Its long legs and powerful jaws made it a perfect predator. It moved with terrifying grace, capable of chasing down even the swiftest prey. In the north, across Laurasia, climates varied from humid jungles to dry savannas. Mountains rose where the land crumpled from tectonic stress, and rivers carved their paths between them. Forests of cycads and ginkgos covered the slopes, while fern meadows stretched into the distance. This variety of environments created new opportunities for evolution. Dinosaurs adapted to every possible niche: small insect eaters, agile runners, armored grazers, and apex predators. The planet had never been so diverse, so alive, and yet, beneath all this life, the Earth was still changing. The breakup of Pangaea continued, slow but relentless. Each year, the continents drifted a little farther apart. New seas widened, bringing moisture to some regions and drought to others. Climates that had once been unified began to split, shaping ecosystems in new directions. Gondwana, the southern landmass, started to divide into what would one day become Africa, South America, Antarctica, and Australia. Laurasia, to the north, fractured into the continents that would form North America, Europe, and Asia. The geography of the modern world was being written piece by piece, and life followed the movement. As the seas opened, new coastlines formed, each one a boundary and a beginning. Creatures that once shared the same lands were now separated by water, forcing evolution down separate paths. Isolation became the mother of diversity. In the newly formed Tethys Sea, marine life exploded in abundance. Coral reefs stretched for hundreds of kilometers, hosting ecosystems more complex than anything before. Giant ammonites swam alongside sleek fish, while ichthyosaurs ruled the open waters. These oceans were the heart of the planet's energy. The winds that passed over them carried moisture to the continents, feeding the forests and swamps. The planet's circulation of air, water, and life was in perfect rhythm. The Jurassic world was Earth's great equilibrium, its moment of harmony before the next wave of change. In this age, the atmosphere shimmered with warmth. Monsoons brought gentle rain rather than floods. Volcanoes still burned along the rift zones, but their eruptions were smaller, steady, and life-giving rather than destructive. The minerals they released fed the soil, turning even barren regions into green plains. It was a rare balance, the calm between storms. But even in this balance, the planet was never truly still. Beneath the calm skies and fertile lands, magma continued to flow through the veins of the Earth. Pressure built in places unseen, and the continents continued their slow drift. The world was expanding, breathing, and preparing for its next chapter. The creatures of the Jurassic Age knew none of this. They lived in the moment, the endless rhythm of rain and sunlight, the cycles of birth and death. To them, this was eternity. Herds of Diplodocus moved across the floodplains, their long tails swinging like pendulums. Stegosaurs with plates like shields grazed beside them, their spiked tails glinting in the light. Predators hunted and rested, while pterosaurs glided overhead, their wings catching the glow of the sun. In the seas, plesiosaurs surfaced to breathe, sending ripples across the water. Ammonites drifted in slow spirals below. It was a living planet, perfect in its balance of life and motion, the rise of the New World was complete. Earth had evolved from a single, unified land into a network of continents and oceans, each shaping the other. No longer a world of extremes, it was now a world of complexity, of ecosystems built on connection, isolation, and renewal. The atmosphere that had nearly suffocated life now sustained it. The oceans that had once burned with volcanic heat now sparkled with coral and motion. The land that had once been a single dry heart was now a collection of living continents, each beating with its own rhythm. And from these rhythms, the story of life continued. The breakup of Pangaea had torn the planet apart, but in doing so, it had given it identity. It had created the diversity that would one day lead to mammals, birds, and eventually us. It had turned a single, silent land into a world of many voices. And though the age of dinosaurs was only beginning, the foundations of the modern Earth had already been laid. This was the rise of the New World, the moment when chaos became order, when fire became life, and when the planet itself began to resemble the home we know today. The continents still drift, the oceans still breathe, and the wind still carries whispers from that ancient time, reminders that our world was born not from peace, but from motion. And motion, as the Earth has always shown, is the truest form of life. Even as the continents drifted apart and the new world rose from the ocean's depths, the memory of Pangaea never disappeared. It lingered in the rocks, in the fossils, in the patterns of wind and current that still circle the planet today. The Earth remembered what it once was, a single heartbeat of land surrounded by endless sea. The age of dinosaurs ruled the surface now, but beneath their thunderous footsteps, the world still carried the echoes of its past. The great mountain chains that split the continents, the deep valleys filled with ancient rivers, the matching coastlines across oceans, all were remnants of the supercontinent's unity. The breakup was slow, but its marks were eternal. In the layers of stone, scientists can still read the story of Pangaea like a book written in fire and ash. They can trace the paths of its deserts, the lines of its rifts, the shapes of its ancient forests now turned to coal. They can see where the lava once flowed, where the oceans once flooded, and where the first seeds of separation began. The Earth keeps its memories, not in words, but in layers. Each stratum of rock is a sentence, each fossil a phrase in the language of time. And when we look closely enough, we can still hear the planet whisper of the time when it was whole. But while the continents drifted apart, their shared origin never vanished completely. Deep below the oceans, the same tectonic forces that tore Pangaea apart continued to connect them through invisible boundaries, the mid-ocean ridges, the molten arteries that still pulse with the planet's heat. The world, though divided, remained one living body. The oceans carried the proof. The same currents that once circled the Panthalassa still echo in the global circulation of today's seas. The winds that shaped the deserts of the interior now sweep across modern continents, guided by the same ancient rhythms. The monsoons that once drenched the coasts of Pangaea still return every year across Asia, Africa, and the Pacific. The Earth's systems never forgot their origins. They simply adapted to the new shape of the world. Even the creatures that lived in this new age carried within them the legacy of the old. The reptiles that had survived the chaos of Pangaea evolved into species that ruled both land and sea. Some would eventually give rise to birds, carrying pieces of the supercontinent's sky into the future. Others would shrink, burrow, and survive the next extinction to become the mammals that would one day inherit the Earth. Every living thing, in its own way, was a fragment of Pangaea's story, a continuation of its will to endure. As millions of years passed, The continents drifted farther apart. New oceans widened between them, separating species, climates, and cultures of life. The diversity that filled the Jurassic world was born from distance, from isolation, and yet, through all this separation, the planet remained interconnected, as if some deep memory still tied it together. It is strange to think that the same forces that destroyed Pangea's unity also created life's greatest variety, that the act of breaking apart became the foundation of creation. But that is how the Earth works. It evolves through chaos, builds through destruction, and finds balance in motion. The echoes of Pangaea were not just geological, they were biological, atmospheric, and emotional, a pulse that still resonates through the planet's living systems. In Africa, the deserts still hold the red sands that once lay at Pangaea's heart. In North America, the Appalachian Mountains still carry the shape of ancient collisions from when continents once met. In Europe and Asia, the fossils of identical plants lie buried in distant soils, proof that they once shared the same forests. And far beneath the Atlantic, the crust of the ocean floor grows outward from a single line of fire, the Mid-Atlantic Ridge, the modern scar of Pangaea's death. It is there that new land is born, even today, as molten rock rises to create the crust that slowly pushes the continents farther apart. The Earth is still breaking, still drifting, still remembering. And in that motion, it continues the legacy of Pangaea, the eternal cycle of unity, separation, and renewal. If we could travel back and look at the planet from space during the age of Pangaea, we would see a world both alien and familiar. One vast land ringed by a single ocean, its surface glowing with deserts, mountains, and storm clouds. It would seem simple, almost peaceful, but hidden within that unity was the tension that would one day shatter it. If we looked at the Earth now, we would see a world divided but alive in ways it never was before. Continents scattered like puzzle pieces across the globe, each carrying its own species, climates, and stories. The planet we live on today is the direct descendant of Pangaea's destruction. Our mountains are its bones, our oceans are its tears, our air, our forests, our lives. All of it traces back to that ancient time when the Earth was one. The echoes of Pangaea still live in us. The continents continue to drift at the same slow pace, only a few centimeters each year. It seems insignificant, but in the language of time, that motion is everything. Given enough millions of years, the world will change again. The Atlantic will widen until new lands vanish beneath it. The Pacific will close. And someday, far in the future, the continents will collide again, forming another supercontinent. Scientists call this future landmass Pangaea Ultima or Amasia, depending on how the plates move. It will rise from the shifting crust, uniting the scattered continents once again. The Earth will repeat its cycle, just as it always has. The story of Pangaea was never about one continent, it was about the heartbeat of a living planet, a heartbeat that never stops. In every earthquake, we can still hear it. In every volcano, in every tide, in every gust of wind that crosses the world, the planet speaks the same truth. Nothing stands still. Everything changes. Everything moves. Everything returns. The memory of one Earth is not just buried in stone, it flows through time, carried by the very forces that shape our existence. The continents that once touched still remember their embrace. The oceans that now separate them still share their breath. And somewhere, deep in the planet's core, the molten heart of the Earth still beats with the rhythm of Pangaea, slow, ancient, eternal, The story of Pangaea was never just about land. It was about time itself, how it moves, how it reshapes, how it remembers. The Earth has always been alive, breathing in continents and exhaling oceans, never still, never finished. Millions of years have passed since Pangaea first formed, since it broke apart, and since its pieces drifted to where they now rest. Yet, deep beneath our feet, the same forces that once united the continents are still at work. The planet is still writing its story, one slow movement at a time. The continents continue to drift, carried by the currents of molten rock that swirl through the mantle. Each inch of movement each year is a heartbeat, a pulse of the same energy that shaped the first supercontinent. And though we measure time in human generations, the Earth measures it in cycles. The cycle of Pangaea was not the first, nor will it be the last. Long before it, there were others, ancient supercontinents, now forgotten by everything except the stone. Columbia, Rodinia, Pannotia. Each one was born, broken, and reborn. Each one carried its own forests, its own oceans, its own living worlds. Each one ended, and from each ending came a beginning. This is the eternal pattern of the planet, the rise and fall of continents, the fusion and the fracture, the endless creation that gives life its rhythm. Pangaea was only one verse in an eternal song. If we could watch the Earth through the eyes of deep time, we would see it breathing. Continents would drift and merge like clouds, mountains would rise and crumble, oceans would appear and disappear. Deserts would bloom, jungles would drown, and every few 100 million years, the world would remake itself entirely. And yet, through all this, life endures. That is the miracle of the planet. Not its stability, but its resilience. The same Earth that was once nothing but molten rock gave birth to oceans, to forests, to creatures that could swim, walk, and fly. It has faced fire, ice, poison, and extinction, and still it continues. The memory of Pangaea is not trapped in fossils alone. It lives in the continents themselves, in the way their shapes fit together like pieces of an ancient puzzle. It lives in the chemistry of the rocks beneath our feet, in the deep ocean ridges that still carry the heat of creation. And, in a quiet, almost poetic way, it lives in us. The oxygen we breathe, the minerals in our bones, the elements in our blood, all were born in the transformations of the Earth. The forests of Pangaea fed the atmosphere we still depend on. The volcanoes that tore it apart created the land we walk on. The oceans that surrounded it evolved into the seas that cradle our coasts. Every breath, every step, every wave is an echo of that ancient world. The cycle continues. The continents we know today, Africa, Europe, Asia, the Americas, Australia, are only temporary shapes. They will not stay as they are. The Atlantic Ocean will keep widening, the Pacific will shrink, and the tectonic plates will once again bring land together. In 200 million years, give or take, the Earth will reunite. The scattered pieces of Pangaea will drift toward each other again, closing the oceans that once separated them. Mountain ranges will rise where the seas used to be. Deserts will form in the new continent's interior, and new forests will grow along its coasts. A new supercontinent will take its place, as it has before and will again. The cycle will repeat, but the memory will remain. Scientists call this process the supercontinent cycle, a dance that has been happening since the planet cooled enough to have a crust. It is not random. It follows a rhythm older than any life. It is the slow heartbeat of the planet. To understand the Earth, we must understand that it does not stand still. Everything we see, the continents, the oceans, even the air, is temporary. But in that impermanence lies beauty. Because nothing lasts forever, everything has meaning. The rise and fall of Pangaea was not a tragedy, it was transformation. The breakup of one world created the diversity of another. Without that separation, there would be no different climates, no distinct species, no vast web of life that covers the planet today. Every bird, every fish, every human being owes their existence to that ancient fracture. The destruction of Pangaea was the creation of us. If we look at a world map now, the pieces of the puzzle are still visible. Africa and South America fit like memory. India's
the cool
path
thing is that
northward
no
can
one
still
is
be
uploading
traced in the
Urbex or-
collision that gave rise to the Himalayas. Antarctica, now frozen, was once lush and green. Every coastline tells a story of connection, of belonging. The Earth still remembers where it was joined, and in that remembrance lies something deeper, a kind of continuity that transcends time. We are living on a planet that never dies, only changes. Its continents shift like thoughts, its oceans move like dreams, its mountains rise and fall like the rhythm of a sleeping giant. Pangaea was only one dream among many, but it was the dream that made the Earth we know. And someday, when the continents merge again, the cycle will continue. New species will evolve, new ecosystems will flourish, and the memory of us will be buried in layers of stone, waiting to be discovered by whatever life comes next. That is the legacy of Pangaea, the understanding that nothing truly ends. The Earth does not destroy itself, it renews. It does not forget, it transforms. And as long as it moves, it lives. The planet's heartbeat can still be felt in every tremor, every wave, every gust of wind. Each is a reminder that we are walking on something alive. The continents we live on are not static. They drift beneath us, carrying us across the surface of time. In that motion lies our connection to everything that has ever been. We are part of the same story that began billions of years ago. The story of rocks and oceans, of fire and breath, of unity and separation. And as we look up at the stars, we can imagine other worlds, like ours planets, circling distant suns, each following their own cycles of creation and destruction, each carrying their own memory of being one. Perhaps somewhere, on a world far away, another Pangaea is forming right now. Perhaps another will one day break apart, giving birth to life. Because this is not just the story of our planet, it is the story of existence itself. Everything begins, everything changes, everything returns. The Earth has always been one. Its continents, its oceans, its life, its history, all connected through time. And even though we now stand on separate shores, divided by vast waters and distant skies, we are still part of the same ancient whole. We are still Pangaea. And as long as the Earth turns, as long as the wind blows and the oceans move, the memory of that unity will never fade. One Earth, one story, forever.